Great. So we are going to start over here. Let's see. Hello, hello, hello. Hello, hello. Okay, what we're going to do is we're going to start over here. We're going to do 8,500. Oh, hold please. There we go. Need to bring this down. Okay, there we go, there we go. All right, 8,559. So when we're looking, we're going to do 8 on the abacus. We do 8, 5, 6, 7, 8, 5, 6, 7, 8. We have 5. That's the value of 5. We do 3, 1, 2, 3, and then we do 9. 5, 6, 7, 8, 9. Welcome, everybody. Welcome. We are learning how to read the abacus. After we learn how to read the abacus, we will go into some doing arithmetic. All right. So, 8. We got to do 8. 5, 6, 7, 8. So we're going to color in 5. And then we're going to color in 1, 2, 3. So we know that 3 plus 5 is 8. The top beat is 5, and it's touching the reckoning bar. Because it's touching the reckoning bar, it's being counted. This is also being counted, right? 1, 2, 3, that's being counted, but this beat is not counted, so it's not being considered part of the reckoning bar. And then we have this number. We have 9, 5, 6, 7, 8, 9. Again, these beads are touching the reckoning bar, so they are counted. So we're going to color in 5. So the top bead is always going to be 5. We have 3, 1, 2, 3. We do 1, 2, 3, and then we do 9. 5, 6, 7, 8, 9. That's what it is. So what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, we will go into doing some addition and subtraction. So the first thing we're going to do is understand how to read it. Hello, everybody. Hello. Thank you for joining. Thank you for joining. Please keep your mind open for something different.
Open your mind to me, please. Open your mind.
So what are we doing right now? We are going to do the next number. It's 5,221. When we're looking, we have 5,000, we have 5, and then 200, 1, 2, 1, 2, and then 1. So we go to color it in. We do 5,000. The top bead will always be 5. The top bead is counted because it's touching this reckoning bar. So we have 5. These beads are not touching the reckoning bar, so it's not counted. The next set is 2. So this is our hundreds. This is 2. Because this is 2, 1, 2, it is a value of 1. 1, 2. Together makes 2. And then notice these two beads are not counted and this bead is not counted. So when we're looking, only these two beads are touching the reckoning bar. It is being counted. And we do it again for the 2 over here. So we do 1, 2, and then we have 1. This is what 1 looks like. 1 is just 1. That's it. So we have 5,221. Welcome, everybody. Welcome. And we're going to do our next number. We do 3,294. So on the abacus, we're going to do 3,000. 1, 2, 3. We have 2, 1, 2, 9. 9 is 5, 6, 7, 8, 9. The top bead will always be 5, no matter what. Thank you so much for liking my live. And then we have, what number? 4. 1, 2, 3, 4. Welcome, everybody. Welcome. We are learning to read the abacus. After we learn to read the abacus, we will go into adding and subtracting. We might be able to do some, I don't know, multiplication and division, but we'll see how the class goes. So the first thing we're going to understand is how to read the abacus. Understanding to read the abacus is the key. The reason why is because that's all that the abacus does. The only thing that it does is it visualizes. It's able to visualize. You're able to visualize your numbers. That's it. Hello, everybody. Hello. Thank you so much for the follow. Oh, hello. I didn't see the comment. Hello. I'm so happy. This program will help so many people and children. Oh, thank you, Daisy's mom. I hope so. Right? I'm hopeful. I'm very hopeful. So we have the next number is 2,610. Oh, my God. Oh, yay. That's fantastic. I don't know what this $100 is. I'm going to have to mute you because I don't know what you're doing. Okay, at least for me. Oh, I'm sorry. There's an echo. Let me check. No, I don't hear an echo. I don't see that I have 2 microphones. Oh, hi, TikTok. I don't know what's going on. All right, fine. We'll do that. Hello. No echo. Okay. So we're going to do 2,610. So when we're looking, we're going to do 4 digits. How are we going to do 4 digits on the abacus? We're going to utilize these 4 digits. These are the columns, right? So we have our thousands, our hundreds, our tens, and our ones. We're going to do 2, 1, 2. We'll do 6, 5, 6, and then we do 1. The bottom bead is a value of 1. Anytime the beads are touching this reckoning bar, it is considered counted. So when we're looking, we have 2, 1, 2. This is 6, 5, 6, and then this is 1. Thank you. Do I have a moderator to take out the spammers? I don't have a moderator, but I don't get a lot of spammers, so I'm okay. Thank you, though. Thank you so much. Hello, Value. Thank you, Gabby. Oh, thank you, Gabby, for letting me know. Yes, I don't know what's going on. Very rarely. Yeah, very rarely. I'm a spammer. Oh, Jayberg. I want to learn. What's this concept called? It is called the abacus. Thank you so much for asking. This is an abacus. An abacus is just counting the tools. Hello, balls on budget. So we have 2, and then we have 6, 5, 6, and then we have 1. 1 is just the 1 bead. And then we have 0. I understand already. Great, Ben. That is awesome. Because why? Why? What? How did I get two phone angles? Sweeter. Thank you. It is because I have a webcam and then I have a desktop document camera. Hello, Jay Berg. I'm so excited. Oh, thank you so much. You got it. You got the abacus from the thrift store? Oh, that's great. What kind of abacus is it? What, Jayberg? We're only trying to read the abacus right now. So when we're looking, we're going to do 3, right? To do 3, I'm going to clear my abacus. This is the first time I've seen how small the camera is. Yeah, it's very small. Hello. See, that's my other one. Hello, Deep Cath. Yes. Okay, so we do 3. We'll do 3. Why is the 1 a 5? That's just the way it is. That's just the way it's designed. So we do 3, 1, 2, 3. Okay? Jayberg. Can you see that? 1, 2, 3. 1, 2, 3. And then we do 4. 1, 2, 3, 4. We do 1, 2, 3, 4. And then we do 6, 5, 6. That's it. 5, 6. Idek! Wait, Idek is here? I just like it. Oh, ha, ha, ha. So we have 6. We're going to do 5, and then we do 6. There we go. And then we do 9. 9 is 5, 6, 7, 8, 9. All we're doing is we're counting and coloring our beads. Anytime the beads are touching this reckoning bar, this is what's being counted. And I got to change my markers. This is 9. So notice that all the beads are touching. That is considered counted. Ha 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 ha. Thank you so much. Why not start from the first column? Thank you so much, gracefully. That's a really good question. I have a dot right here. If you see that, there is a label. This label is my ones label. Because this is my ones label, I have my place value. I have my ones, tens, hundreds, thousands, and then 10,000s. And so we have our decimal. Our decimal sits between our ones and our tenths, and it sits right here. So for those of you that are interested, I do sell this abacus available in my shop. We are looking to, this is made out of plastic, and there's 7 columns. 1, 2, 3, 4, 5, 6, 7. There are 2 labels. One is for the ones, and one is for the thousands. And then notice I have my decimals over here. I have my tenths, and I have my hundreds. If you wanted to, though, however, if you wanted to, just like a Pokemon,
I choose you.
I could choose this one over here to make it a ones place, and I move everything over. So then it would be ones and tens, and then all of this would be my decimal. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Whoa, that's 10. 10, 20, 30, 40, and then 50, 60, 70, 80, 90. But notice I have no more room for 100. So because I have no more room for 100, that's why I choose this one over here. However, if I wanted to make a really, really small number, If I wanted to make a really small number, I could do 90,000.00001. I could do that. Oh, that's not right. There we go. Yep. So, I'm sorry. Hey, Sassy, welcome. Welcome. I do remember you. Why is it a better option than something modern or a piece of technology? Because here, Jayberg, here's a question. Do you cook? Here's a question. Do you cook? Do you cook with like fire, pans, on a stove? Do you cook? In respect to the yes. Well, you either cook or you use a microwave. So why don't you just use a microwave? Because it's better, right? I mean, that's the process. It's better to cook. It's better to bake, right? You could bake in a microwave, but it's better to bake in an oven. Using your brain is the greatest thing, right? And what we're trying to do is we're trying to deter dementia, because this is like brain gymnastics. That's what it is. It's like brain gymnastics. Okay, so I have a lot of concepts. I have a lot of things. Okay, so, do we know why we started from the left row? The reason why we started, thank you, Catharsis. Okay, why not start from here? Because I have my place value. I think I answered that, right? There's a lot of comments. I'm sorry. Hello, Robert. Welcome back, Robert. Hello, Middle Cat. Yes, thank you. Brain gymnastics. This is great. Okay, good. So we have our ones. This is our ones place. This is the ones. This is why I start in the middle. Okay, so we're going to go back. We're going to do 6,971. So notice I have 4 digits, 1, 2, 3, 4. I'm going to use 4 columns, 1, 2, 3, 4. I'm going to do 6. We have 5, 6. We have 9, 5, 6, 7, 8, 9. We have 7. We have 5, 6, 7, and then we have 1. So we are visualizing our numbers. We have 6, 9, 7, 1. Anytime the beads are touching the reckoning bar, that's what's being counted. Hello, Daylin! I don't use paper in math. That's fantastic, Ben! Showing work is showing work is always an issue, but you have to show the professor or the teacher how you got it, because they want to learn too. That's how I see it. You want to teach the person reading and grading your stuff. So these ones are not counted. Why? Because they're not touching the reckoning bar. Only these 2 beads are counted. These 3 is not counted. All of this is counted because they're touching the reckoning bar, and then these 3 is counted because these are touching the reckoning bar, and this 1 is touching. Notice the top bead is not touching, so it's not counted. So when we look, we have 6, 9, 7, 1. Cool? And then we're going to color it in. We're going to do 6, 9, 7, 1. And there we are. There we go. I'm on level 4. Oh, level 4 gifted child. We'll be showing the work. So we're going to do 15. Remember me? Yes, I do remember you, Sassy. I do remember you. Welcome back. So the next number we're going to do is 1,500. So I'm going to clear my abacus. So I cleared my abacus. This is all 0. So this is all 0. So this is my reckoning bar, and I'm going to clear my abacus. I cleared my abacus. I'm going to do 1,500. 1,500, 0. So this is 1, this is 5, this is 0, and 0. Yes, it is. You're absolutely right, Middle Cat. Thank you. Oh, yeah, not a problem, Coma. Brock system is... Do you only teach... Yes, I only teach arithmetic. Maybe calculus. Asking for a friend. If you're looking for a calculus, I know a friend. So DM me and I'll tell you who it is. I don't think he's here right now, but DM me and I'll send you to somebody who knows calculus. Yeah? So we have 1, Maddie. Do you understand that this is 1? Because it's touching the horizontal bar. This is my reckoning bar. This is what counts. This is 5. That's it. That's all it is. This is 1. That's 1. That's 1, 1, 1. These are all 1s. Does that make sense? So then, thank you for the follow, Koma. Thank you for the follow. Okay, it looks kind of easy. I get it. It's kind of easy. Of course it's easy, Jayberg. Yeah? Okay, good. So then, this is 2. 1, 2. That's 2. Make sense? 1, 2, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So is green always 1? No, green is not always 1. It is the item of 1. Oh, thank you, Albert. No, I apologize. It is above my pay grade. So if I do 2, that's 1, 2. That's what 1, 2 is. It can be these two. It can be these two. It could be these two, right? If I want to subtract, I have 4. I can take away 1. That's all I'm doing. I want to take away 1 here, or I want to take away 1 here. So does that make sense, Gabby? So the 1, it just means 1, not the green is 1. I mean, green is kind of 1. But if I have all of this and I take away this, that's 4. Does that make sense? So if I do this, that's 4. But if I do this, this is 1. But then if I go up, right, then it's 1. Yeah. So what are we doing? Okay. So Maddie, are you a teacher before something? Were you a teacher before or something? I was a teacher. I am a teacher. What are you talking about? I am a teacher. I am a teacher. Okay, what are we doing? So we're going to do 1500. We're going to do 1500. We got 1, and we got 5, right? 1, 5, 0, 0. That's all we're doing. That's all we're doing. Yes, you're right. 0, 0. That's it. That's it. Kind of makes sense. Oh, good, Maddie. So like each beat is 1. Yes. Oh, well, except for the top beat. The top beat will always be 5. I'm sorry, I forgot, Gabby. So we have 1, right? I'm going to count 1. That's 1. We have 2. This is 2. This is 3. That's 3. This is 4. This is 4, right? 1, 2, 3, 4. And oh, sorry, you can't see that, right? 1, 2, 3, 4. And then what's 5? 5 will always be the top beat. 5 is that. That's all it is. 5, no matter what. This is like a nickel, right? That's a nickel. So we have 6, that's 6. We have 7, we have 7. We have 8, we have 8. And then 9, 9. 5, 6, 7, 8, 9. 5, 6, 7, 8, 9. 10 looks like that. 10 is a 1 and a 0. That's it. 1 and a 0. Oh, good, Gabby. Good. I'm so happy. Thank you, Jay Berg. I appreciate that. So we have 1 and a 0. We can do 11, 12, 13, 14, 15, 16, 17, 18, 19. So now when we look, I want to do 1500. 1500 is a 1 and a 5. 0, 0. That's why we do that. That's why. Good job, Maddie. So what's our next number? Our next number is going to be 8. So we do 8, 5, 6, 7, 8. We do 6, 1, and 1. 5, 6, 7, 8, right? 5, 6. So we do 8,611. So that's what it is. So notice that these beads are not touching the reckoning bar, so they're not being counted. So we have 8,611. And I'm going to color it in on my abacus. I'm going to do 8,600. Oh, sorry. Oops. That's a wrong one. And then 11. All right. We're going to do the next one. The next one is 8,179. So we're going to do 8,179. And I'm going to color it in. We do 5, 6, 7, 8. We do 1. This is 1. We have 7, 5, 6, 7, 5, 6, 7. And we do 9. 5, 6, 7, 8, 9. There it is. 5, 6, 7, 8, 9. Welcome, welcome, welcome. I couldn't find. It's over here. It's over here, not in my TikTok shop. It's not available in my TikTok shop. You want to wait, or it's over here. Okay. I might be slow. Oh, hi, British. The 2 lasses are the decimal places. Yes, thank you. Toad. Okay, why not start from the right? Yes, why not start from the right? Yes. Wait, did you say 6, 7? I think I did. No, I didn't. I said 7, 9. Makes sense. Great. Yeah. Thank you, everybody. Thank you. I'd rather give you my money. Okay, then you can wait. If you want to wait like a month, I'm sorry. I apologize. Because I'm trying to bring it into the shop, but it takes some time to bring it in. So I apologize. Yes. So when we're looking, the last 2 digits are the decimals. So we have our ones. If you notice there's a dot here, we have our ones, and then we have our tenths and our hundredths. That's it. So when we're looking, I'm still going to get something. Okay. Okay, I appreciate that, Robert. Okay, wait. Okay, so 6, 7. 60, right? 5, 6, and then 7. 5, 6, 7. That's what it is. 5, 6, 7. Okay, what's next? We're going to do 3,161. So we're going to do 3,000. 1, 2, 3. That's the thousands. We do 100. We have 60. And then 1. That's it. So we have 3,000, 1, 2, 3. We have 1, because that's the 1. We have 6, 60, 5, 6, 5, 6. Notice none of these 5s are touching. So if they're not touching, then that's not being counted. So then we have 1. That's what 1 looks like. Now I'm going to color it in. When I'm done coloring, when I'm done with this maze, I hope you guys will be ready because we will be working on, you're going to have to tell me. You're going to have to tell me. We're almost done. We're almost done. Okay, so the next number is 5,315. Hello. Hi, Char. Welcome back. Is there a real life use for this? Yes, Easton. It is for brain gymnastics. So for if you want to not have dementia, if you want to be smart, if you want to be in school and not needing the calculator, you could do it. Okay, so what are we doing? You decide. Oh, do you? Oh yeah, that's right. Do you decide where the decimals are, or it tells you? The abacus will tell me. I don't need to decide. So I have my ones. My decimal sits after my ones, just like how we write. So we have our ones, our tenths, and our hundredths. You haven't even lied. You can't even lie. It's like, yeah, you can't lie. Oh, but you do have to be careful though, right? You have to be careful because you have to hold the abacus, because if you don't, then you're going to answer. Your answer is going to get messed up. Okay, so what we're going to do? We're going to do 5. We do 5, 3, 1, 2, 3, 1, and then 5. I think this is great. This is like, thank you everybody. Thank you everybody for joining. Thank you everybody for joining. Please keep your mind open.
Now, open your mind to me, please. Open your mind.
So what we did is we did 5,000. This is 5, right? 300, 1, 2, 3. We do 1. That's 1. And then this is 5. So we did 5,315. And then our final answer will be, I'm going to clear my abacus. We have 9,249. So look, if you notice, these two top beads are not counted. So that means this is 2 and then this is 4. However, these two are counted. So this is 9 and this is 9. So when I color it in, I do 9,249. That's it. Hello. Consider it open. Yes. So the top line, yes, the top line will be 5555555. Yeah. So when we're looking, I'm a math professor teaching basic math, and this is really awesome. Oh, that's fantastic. Thank you so much for dropping by. So when we're looking, we're visualizing our numbers, and that's the greatest thing about abacus. It visualizes your numbers. But there's other things to do the abacus, and that's what we have to do is understand formulas. Formulas is the concepts that we also teach as well. So, but the first thing we're going to do is we're going to understand. Great, Alyssa. The first thing we're going to do is understand. Thank you, keyhole. Consider it open. That we're going to do how to read the abacus. Is there a way to do addition, subtraction, multiplication, division easier than paper? Yes, it's on the abacus. It is on the abacus. All right, so the first thing we're going to do is, guess what? It's going to be your turn. I need my papers. Where's my papers? Oh, here it is. All right, we'll do this. All right, for those of you that are interested, let me know what you think this number is. Now it's your turn. Okay, what number do you guys think this is? Hello. Char. Okay, yes. Thank you, Char. So we have this number, this number, this number, this number. What number do you think that is? At least until I... Thank you, Alyssa. We have 7,921. Well done. Almost keyhole. 8 looks like this. 9 looks like this. Well done, everybody. Wow. Thank you, Middle Cat. Ooh, excuse me. Yeah. It's very loud in my neighborhood. All right. What do we have? We have thousands, hundreds, tens, and ones. What number do you think that is? I used to have crazy teacher that loved to show new stuff and say, take that. I really like that, poetic. I really like that. All right. So we have 1,000, 1,300, 1, 2, 3. We have 8, 5, 6, 7, 8, and then 4. 1, 2, 3, 4. It is amazing and how many trolls come into this live. Thank you guys so much for the gifts. It's amazing on how many trolls come into this live and just want to stay ignorant. Okay, our next number. What is our next number? Thank you, guys. It is absolutely right. You're absolutely right. Thank you, Gabby. It is this one. Wow, Gripix, Daisy's mom. Thank you so much for checking in. Thank you, Friendship. Thank you, Ben, for checking in. Thank you for the lightning bolt. Thank you, Dr. Guy, for the heart me. For those of you that are interested, please check in for the orange heart me. Thank you so much. Hey, how are you doing? I'm doing fantastic, B. I'm locked. So we're going to do thousands, hundreds, tens, and ones. What number do we think that is? Oh, Gabby. 7. Almost, Gabby. Oh, there you go. It was a typo. It was a typo. Well done. Well done. Yes, thank you, Nash. Thank you, Gabby. Whew. Thank you, Ben. Ben Nasher. Sorry. I'm locked. Oh, good, Easton. So what we're doing is thank you so much for checking in. Thank you, Graceful. Okay, constricted. I don't know what that means. Is it 3? No, it's not 3. It's not 3. So how do I know it's not 3? Because this is what 3 looks like. 1, 2, 3. We actually have the top bead. The top bead is a value of 5. So we have 5, 6, 7. There is a 1. This is not 1. This is 1. This is 5. And then 4, that's what 4 looks like. And that's what 2 looks like. But because we have the top beat is 5, we have 5, 6, 7, 8. Does that make sense? So when we're looking, oh yeah, here you go. When we're looking, every top beat, hello, AI TikTok God, welcome back. Thank you so much for the share. Yeah, so Shakira, when you look, the top beat will always be a value of 5. Thank you so much for the follow. What? Didn't you follow me already? Thank you so much for the share, AI TikTok God. Thank you, thank you. So when we're looking, we want to look at the horizontal bar. This horizontal bar is what tracks our numbers, and the top bead is always a value of 5. Yes! So it's 5, 7, 5, 8, 2. Well done! The blue beads are 5, and the color ones are 1. Exactly. Thank you, B. Thank you. Thank you, B. I don't mean to call you B, but you know what I mean, right? Fantastic. Okay, what's our next number? So we have our thousands, hundreds, tens, and ones. I know what you mean. You know, my cousin's name is... her nickname is Baby, and so we call her B. So that's what I feel like. I feel like I'm calling you my cousin, if that's helpful. Thank you so much, Easton, for the share. Thank you so much. B, like a queen bee. Queen bee. That's a good one. Okay, right? I'll call you Queen Bee. Thank you, Easton, so much for the share. That's what people call me, B. Okay, good. Okay, good. So yes, that's right, Janet. Thank you so much. Thank you, Shakira. 3, 1, 2, 3,200, 1, 2, and then 9, 5, 6, 7, 8, 9, and then 5. You're well done. Good job. Oh yeah, it was a typo. Hey, Kay, welcome, welcome, welcome. It is 3,295. 3,295. Thank you, everybody. Thank you so much for commenting. So we have our thousands, our hundreds, our tens, and our ones. How are we doing? I've never learned. Oh. Thank you, Marley. Yes, thank you. Yes, I appreciate that you keep your mind open. Thank you, everybody, for joining.
Welcome to the real world.
Yes, thank you. It is 1,784. Well done. Yes, it is 4. 1, 2, 3, 4. Well done. Well done. So we have 1,784. So what's our next number? Our next number. What's our next number? We have our thousands. We have our hundreds, our tens, and we have our ones. But wait, there's more. Open your mind to me. I got it. Oh, this one.
Now open your mind to me, please. Open your mind.
Thank you. It is 5,869. Thank you, Poetic Equation. Thank you, B. Thank you, K Win and Alyssa and Char. Marley, Janet, thank you guys so much. Yes, it is 5,869. Well done. I looked too fast. It's okay. It's okay. I understand. Thank you. Thank you. Thank you, AI TikTok God, for checking in and going into the heart me. Thank you so much. So we have our thousands, our hundreds, our tens, and our ones. Well done. Ah. Oh, Poetic Equation. Thank you so much. Alyssa, thank you. Yes, Char. Yes, Janet. Yes, Shakira. Oh, there we go. There we go. Do you ever look at Mulan? Oh, I did. I did. I saw it. I did. I gotta hold on. I found it. I found it. It was one of the things I made sure I looked at before I left. And so, where is it? It is over here. So for those of you that are interested, here we go. Yep. And so, what was it? Here. I need to see what I'm doing. There we go. No. There we go. Okay. No. There we go. There we go. Here we go. Okay. So, for those of you that are interested, we have Abacus is everywhere. So the first thing, I don't know if you guys know, it's actually a character in Wonka. Guess what? The character's name is Abacus Crunch. Whoop, whoop, whoop. This is fun. I'll be back. Okay, K-Win, have a good night, and I'll see you in the next live. So then the other one was Penguins of Madagascar. Penguins of Madagascar actually has Kowalski, and Kowalski actually upchucks, an abacus. And then here's the other one, Soul. So Soul has the abacus. This is not really a true abacus. It has too many beads. I don't know why there's so many beads. I think it's a little bit wrong. And then Fairy Mary actually uses an abacus. This one is a 1, 2, 3. I think this one's incorrect as well, but it is what it is, right? And then we got Moulin Rouge. Moulin Rouge, there is the Fa family ancestors, and they're deceased members of the Fa family. So what's going to happen is this is also incorrect. No, it's right. 1, 2, 3, 4, and then we have the 5. So now you guys can read it. If you look, what number do you think he has on the abacus? What number do you think it is? 5, 6, 7, 8. Ha ha ha. What number do you guys think that is? It's a really big number. It's not that big. 1, 2, 3, 4, 5. There's 5 digits. There's going to be 5 at the top. Yes, 5 will always be at the top no matter what. There's more than 4 digits. Thank you. Yes, Totuma. Yes, 5, 8, 7, 6, 6, 1. 8. Shakira, it's 8. Because there's the 1 beat at the bottom. Oh, maybe I gotta make it bigger. There we go. Is that better? There we go. Typo. So it's 8, 7, 6, 6. Don't forget the 1. Right. So, yes. Thank you so much, B, for that. Can't see the fit. Oh, yeah. Okay, there you go. So then, what else is it? Yep, and that's it. So then I had the book. There was a book. This book, she is blind, and she makes an abacus out of acorns and branches. This one is a game. Inside the game, there is a person that uses the pulverizing abacus, which is kind of strange. And then I found another one. Who's heard of Dragon Quest? Dragon Quest has abracadabra. Abracadabracus. And they use this. And it's right. And then the final one is the match factory. In the match factory, they use an abacus. Can you see it? There you go. So that's it. That's where we found it. Thank you, everybody. Where are we? Are we doing this one? There we go. Hello. Welcome back. Welcome back. A little bit of a break. So we're back to here. We did that number, and then we're going to go down to here. What number do you think that is? I hope it would be accurate since ancient. You know, some of them are not accurate. Some of them are not accurate. But can you show a blind girl an acorn? Oh, sorry. Hold on. Yeah, it's called Hannah. So the blind girl. It's a Gloria Whalen. It's a National Book Award winner. Okay, I hope. Okay, and then there's the book. Yep. I think a lot of folks, they think it's cool and don't realize the usefulness. Yeah. How can you learn to add and do simple operations in the abacus? We will get to that. What is an abacus? An abacus is you're welcome, Poetic. An abacus is a counting tool. That's what it is. It's a counting tool. That's all it is. It just tracks your numbers. It makes you look at your abacus. It makes you visualize numbers, which is crazy. So crazy. All right. So for those of you that are interested, thank you so much. Oh, Alyssa, thank you. Oh, you're welcome, Poetic. You're welcome. You're welcome. Okay. What number do we think this is? Whoa. Jackson, does that make sense? This is an abacus. An abacus is a counting tool. So our next number is thousands, hundreds, tens, and ones. What number do we think that is? So we have our 2. Yes, 2, 9, 2, 1, 2. We have 9. 5, 6, 7, 8, 9. 3, 1, 2, 3. Thank you, Middle Cat. Thank you, Poetic. And then we have 9 again. 5, 6, 7, 8, 9. Well done, well done. And then our next number is... So what we're doing is we're learning how to read the abacus. After we learn how to read the abacus, then I'll show you how to do adding, subtracting. Oh, Fairy Mary needs a Tinkerbell to correct her abacus. Yeah, for sure. Yes, 47, 47. Almost, Alyssa. Because the 5 is not touching. So you're right. It is 47. 47. Well done, well done. So then our next number is, we have thousands, hundreds, tens, and ones. We have thousands. All these beads are touching the horizontal bar, so these are counted. None of these are touching, so these are not counted. This is not counted, and none of these are counted. So when we're looking, it is 9,918. Well done. Well done. So we have 9,918. And then we have our next number. I have my thousands, my hundreds, my tens, and my ones. What number do we think that is? Can we see? There we go. Oh, thank you, Totuma. Thank you so much. Yes, Poetic. Thank you, Alyssa. 6, 6, 7, 1. Well done, Shakira. Awesome, Alyssa. Thank you, guys. And this is the end. This is the last number. So what we did is we just did a maze. This is my maze. And so we have thousands, hundreds. That's not right. Hundreds, tens, and ones. There we go. What number do we think? Yes, thank you, Poetic. Thank you, Totuma. There we go, Tatuma. I think I said it right. Thank you, Shakira, for the rose. Okay, so it is 2,730, 1, 2, 3, and then 9. Well done. Okay, so Now, what are we going to do? We're going to start learning how to add and subtract, right? So it will all make sense pretty soon. So on the abacus, the first thing we're going to do is understand what? We're going to understand that when we look, there's the beads. When you look at the beads, there's an edge. Because there's an edge, what we're going to do is we're going to just gently move the beads. That's all we're going to do. We're going to gently move the beads. If you are aggressive, then your answer will be wrong. Why? Because the beads are so easy to move. And so when we do this, you don't want to flick. Don't flick.
And flick. Oh, you flick too hard, damn it!
Don't flick. Because if you flick, then your answer becomes wrong. So what we want to do is we want to move the beads with intention. Hello, Brett. When we look, let's do a little review for Brett. We do 1, 2, 3, 4. These beads are touching this horizontal bar. That's what's being counted. We do 5. Hello, Mr. Benson. Mr. Benson. Just got here. What's blue 5s? S. Yes, you're right. That's the 5. That's the 5. That's the value of 5. So when we're looking, we'll pretend that this is a 5, just like the nickel. Nickel is a 5. And then we can do 6, 6. We have 7, we have 7. We have 8, we have 8. And then we have 9. That's 9. And when we're looking, hello, Big Al! Welcome back! Welcome back! Move the beads with intention. Varies. Middle cat. So we do 10. That's what 10 looks like. 10 is a 1 and a 0. When we look, we have our place values. Every column is a place values. We have our 1s, our 10s, our 100s, our 1000s, our 10,000s. So when we have this is our 10s. 1 10s. That's what we're doing. 1 10s. Then we do 20, 30, 40, 50, 60, 70, 80, 90. Okay, so what we're going to do now is notice that there's a reason why I'm over here because I have a dot over here. But just like a Pokemon, you just want to use one of them, right? There's 2 dots. Just use one. So I use this one. Notice if I have this one here, then it tells me my comma, my thousands. So when we're looking, we have our hundreds, we have our ones, and then we have our thousands. However, I could choose this one, like a Pokemon, to be my ones place.
Pokemon, I choose you!
Then I would move everything over. I could do 100, but I can't. Because if you look, I can only do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 10, 11, 10, 20, 30, 40, 50, 60, 70, 80, 90, and then I have no more room for hundreds. But it's okay, because if I wanted to, depending on how big the number is, I can have a really, really small number, because I can do decimals. So when I look at it, I could be 90,000.00001. That's what it would look like. What is this for? This is for counting. This is to see your numbers. We have 9. So 5, 6, 7, 8, 9. And then this is 1. That's what it is. And then our decimal sits over here. But if I choose this one to be my Pokemon.
Okay, Charizard, I choose you!
Then I can move everything over and it would look like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So Cole had the question, which is, what is 100? That is what 100 looks like. 100 looks like 100. Well, this is 1,000. 1000, right? Why is that? Because none of these beads are touching this horizontal bar, so these are all considered 0. This is the only one that's counted, so this is called counted, right? So this is 1. When we look, this is 10. 10,000. Because I said that this is my ones place. When we're looking, 1.11. We could do that. We could do 2.22. And then 3.33. Oh, good, Alyssa. Thank you. Alex, are you being mean? No need to be, no need to be mean. I can mute you right now because you're being mean. Sorry about that, Alyssa. I apologize. We aren't doing that. Yeah, thank you, B. How do you do expressions work with the abacus? Do you just see it and split it technically? Yeah? I don't even know what that means. That is above my pay grade. I'm sorry, John Newton. I don't know what expressions you're talking about. Okay, so now what we're going to do is we're going to understand when we add. Yeah. Oh, yeah, I don't like people being mean. It doesn't matter on it doesn't matter about speed. It's all about understanding because we're just unfamiliar. We're unfamiliar about, you know what I mean? This is a new concept. This is very this is very new. So I like to say it's unfamiliar. Nobody is I don't like people being inconsiderate. Anyways, yes, thank you, B. We're here to learn. Yes, thank you. And you know what? You're always welcome to ask questions about the abacus. People ask me about calculus. I apologize. I don't know calculus. People ask me about algebra. Again, I don't know algebra. I only know arithmetic. I am here to tell you how to add, subtract, multiply, and divide. We can do a little bit of distributive property. We can do a little bit about isolating the variables. But other than that, that's as far as I go. I feel like we lose things as time goes on. I believe it's easier ways to do. I believe they had easier ways. Oh, you know what? Interesting thing is this is still very popular. Oh my God. The other thing I found out. So remember, B, in the morning we had a discussion like who uses the who uses the imperial system for measuring and stuff. So America, Liberia, and Myanmar. So there's three countries that still use the imperial system. Everywhere else in the world uses the metric system. Funny. Surprisingly, I consider myself unsmart. Show me I get and explain. It don't. Right, 3. It's so crazy. It's so crazy. All right, so here's my book. This book is meant to get the kids young. The reason why is because in Abacus World, we always start the kids at age 5. But I'm like, why are we starting at the age of 5? The reason, I don't understand why. What we should do is start them young because when they start learning how to count, they should know how to read the abacus as well as learning how to count. So they should know that this is 0, and then on the abacus, it is 0. We know that that's 0. So we have 1, 2, 3, 4, and then what I do is I have other activities to strengthen the idea and the concepts of what the number is and what the number is on the abacus and what it means to be here, right? So what we're doing is we're counting how many items, and then they're going to relate it to the number, and they're going to relate it to the abacus. So the idea here was to strengthen the idea, and then we have pixel art, and then we have more counting in circles. So this is lesson 2. Lesson 2 talks about 5 all the way to 9. So the reason why I broke it up is because I wanted to get them to understand that they count from 5. So this is 5, this is 6. We have 5, 6, 7, right? And then 5, 6, 7, 8. And then we have 5, 6, 7, 8, 9. Metric is easier. Metric is a lot easier. So, and then these are just more activities all about the abacus, and I try to make it interactive. I try to make it a little bit interesting, and again, pixel art and drawing mazes, and then we start counting forward. We count backwards. After counting backwards, we count what comes in between. This is just a flip through of what the activities are in the book. So you count what's in between. So here we are understanding what's in between. So if I give you the 2 numbers, understand what that is. And then what do? We do surrounding. If I give you the number, what's surrounding what are the 2 numbers surrounding it? And then after that, we talk about greater than, less than. We do comparison. That's what we're doing. Okay, so the next thing we're going to do is we're going to start understanding how to add and subtract. Now, in the abacus world, so just so you know, in the abacus world, we are going to marry the process and divorce the result. We do not focus on the result. I know in mainstream math, in elementary school, there's a focus on the result, which is, I feel, very difficult. However, on the abacus, what we do is we focus on the process. Why? Because it will always tell us whether or not we're going to need to use a formula or not. The second number will always dictate whether or not we need the formula. So when we look at it, hello, Mexi. When we look at it, we're looking at the second number. How do you add the 1? So the question is I have 7 on the abacus. 5, 6, 7. I have 7 on the abacus, and then I want to add the 1. Can I add the 1? Yes, I can. I can add the 1. Why? Because I have enough beads to add the 1. So the process is to understand that when we move 1 bead, that's all I'm doing. I'm moving 1 bead. So if I have 8, I want to move this one bead. It doesn't matter. It doesn't matter. It just, I want to add the one bead. So my final answer is 9. Again, what we're doing is we're understanding how to move this, what to do with the second number. So my number here is 7. We have 5, 6, 7. I want to add 2. Can I do it?
Come on, do it. Do it.
Yes, I can. 1, 2. So my final answer is 9. So then the other one is, so in mainstream they do dots, which is fine. You could do dots, not a problem. But in Abacus, we don't need to do dots because we could see it. We can subitize, just like these tally marks. The tally marks is kind of like Abacus, right? It's kind of like understanding with the 5. So we have the 5, which is the grouping of here. And then we have 3. 1, 2, 3. So when we're looking, we can subitize that this is 8. Notice what? I can actually scale this. Right? What does that mean? I could do 50, 50, plus 30. 1, 2, 3, plus 30 equals 80. See? Equals, yes, I see. So when we're looking, we can actually subitize. What does subitize meaning? Subitize means that if I look at a number, I know what it is. It is very difficult to look at this number and know what it is. I will tell you right now, this is 50 plus 30. Whereas on the Abacus, you could see if I do 50 plus 30. You could scale it up one more. You could scale it up one more. We could do 500 plus 300. 1, 2, 3. So then we have 800. 800. We have 5, 6, 7, 8, and 0, 0. So when we're looking, every column is a place value. Hello, Selena. Hello, Selena. Hold on just a moment. We are still continuing on with my thought because I'm on a roll. So let's do this. We're going to do adding the 5. We want to add the 4. To add the 4, notice I'm going to move the beads up to the horizontal bar. What I did, I have the 5, the value of 5, and I'm going to move it up. So we have 1, 2, 3, 4. My final answer is 9. How did the Romans know how to do this? The Romans did 10. So they did beads of 10. So when we move the Japanese made it more efficient. This is a Japanese abacus, and they made it more efficient. We're going to add 2. When we add 2, notice I go to the horizontal bar. I want to subtract 2. I want to subtract 1. I'm sorry, I want to subtract 1. Because I want to subtract 1, all I got to do is remove it away from the horizontal bar like that. So my final answer is 1. So when we're looking, right, we have 2. 1, 2. And I want to take away, you just go the opposite. So it's not a different strategy. You know how to add, you will know how to subtract. So we have it again. If I have 3 on the abacus, 1, 2, 3, right? I want to take away 2, 1, 2. That's all I'm doing. And so my final answer is 2. And then we could do it again with the 3. I have 4 on the abacus. 1, 2, 3, 4. Selena, does that make sense how 4 it is? And then we have take away 3. 1, 2, 3. I'm going to be a big person and take away 3 just like that. That's what it is. You're right. Because the other ones, I think Chinese has a 10 at the top, not a 5. Would the Roman argue that their abacus is more efficient? No. So the blue bead is 5. Yes, the blue bead's always 5. No, the Romans would not argue that theirs is more efficient because the Romans would be... Because what they do is they count up. There's a lot of counting up. That's what mainstream math does. Mainstream math counts up. And so the concept is very different. Isn't that saying 4 take away 1? Faceless founder. Isn't that saying 4 take away 1? 4 take away 3. 1, 2, 3. 1, 2, 3 equals to 1. That's what that means. So, yeah. So in right now, public school, mainstream math is a lot of counting up. And that's what Chinese abacus does. The Chinese abacus does a lot of counting up. The Japanese abacus, the Japanese method, the abacus methodology that's being taught now, the more modern, is about concepts. We will get into that. I'll show you what I'm talking about. But the first thing we're going to do is we're going to continue to understand how to move the beads. Did you see the way they teach the math students now? It's a bit different. It is a bit different. They're trying to follow, Yes. So I was doing research on the math that they're doing now, and it follows kind of like the abacus method, but they're doing it on paper, which is really interesting. Oh, good, Selena. Makes sense. Good. Yeah, poetic. I was reading up on what new math when they do new math with multiplication, and they're starting to do distributive property. They're finally doing distributive property in multiplication. But because you're putting it on paper, they need to add the extra zeros, and I can show you that in a little bit. So we have 3 on the abacus, 1, 2, 3, and then want to add the 5. To add the 5, that's all I got to do. So my final answer is 8. And then when we add 7, right? What is 7? We have 1 on the abacus. We want to add 7. Add 7 is the 1 top beat and 2 bottom beats, and we just bring it together like that. We pinch it. So we push it apart. We add it. To take it away is the same thing as adding it, but it's just in reverse. So when we're looking, right, that's all we're doing. If I have 9, right, I bring it all together. I have 9, and I want to take away 8. If I want to take away 8, notice all I got to do is minus 8. 5, 6, 7, 8. Just take it away like that. So my final answer is 1. Right? And then when we look, if I have 9 and I want to take away 5, all I got to do is move it away from the horizontal bar. So what we just did is moving the beads. When we move the beads is understanding what we're doing. So now we get to the point where we're going to start using formulas. And this is where it becomes more efficient, and it's very different. It is very different from the Chinese abacus, and is very different from the Roman abacus. Because the Roman abacus still does a 1-to-1, and the same thing with the Chinese abacus. Here's a Chinese abacus. So the Chinese abacus, they made it into a frame, and they broken it up. So when we count, we do 1, 2, 3, 4, 5. We have 6. I'm sorry. Because we have 5, we're going to count it. We're going to trade it in to make this a 5. So then we have 5, 6, 7, 8, 9, 10. Because we have this, there's a 5 here. We're going to trade that in. So now we have 10. But because we have 10 here, we're going to trade that in to make this a 10. So it's very similar to the Japanese abacus, but we don't have to trade in on the Japanese abacus. Thank you so much for the follow. Thank you, Katie, for the follow and the light bringer. Hello, Daylin. Oh, good. So we have 1, 2, 3, 4, and then 5, 6, 7, 8, 9, and then 10. But notice on the Chinese abacus, there's no notches. I think it's because they don't have change in China, right? But in America, we start having change, and because we're using a lot of money, they decided to put in notches. So that we have our tenths and our hundredths. I think that's what it is. That's a theory. What's the brown one? This brown one? This one's the Chinese abacus. How big of a number can you represent on this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what's 11 digits? I don't even know what it is. I could tell you on the abacus. So we do 9999999. 99,000. All right, I'm back. Zoe, welcome back. So, can I do, hold on. 1, 2, 3, 4, I'm sorry, 1, 2, wait, hold on. Let me see that. I don't know how many zeros that is. Okay, we have 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1. So we go comma, 1, 2, 3, comma. Okay, so I got it. Got it. No, that's not the biggest number because it's a 1. Why does it have 2 beads on top instead of 1? Oh, because it's a Chinese abacus. This is a Chinese abacus. And there's 5 beads here. 1, 2, 3, 4, 5. That's why. And then the top, these are always 5. This is 5 plus 5. 5 plus 5 is 10. So because this is 10, then you do that. That's a 10, right? So that's what trading, you have to trade it in. Okay, so I would have to use my 13 column abacus, but I can go higher, right? So 1,000, ones, tens, I'm sorry, ones, thousands, millions, billions, and then trillions. So I can do trillions, but this is thousands, millions, billions. So that'd be here. If I choose this one to be my ones, that's what it look like. Ones, ones, thousands, millions. Oops, sorry. Right? Thousands, millions, billions. I gotta do ones, thousand, billions, millions, billions, tens. There it is. Yeah. I forgot the 9. Yeah. Is it 100 million? No, it's a trillion. 9 trillion. So I can do 9,999,999,999,999. I was looking to buy an abacus. I saw these 2 different ones. Confused me, so I stopped here. Oh, hey! Okay, 99 billion. No, this one I can do trillion. This one I can do trillion. Okay, so the 2 abacus that you're looking for, Faceless Founder, what are you looking for? Are you looking at this one, or are you looking at this one and this one? Let me know. I have the 7 column. This is a 7 column. The 7 column is nice for young children, or if you like to look at colors. I like to look at colors, so I like this one. This one is a 13 column abacus. It's exactly the same, but it's a single color. It's 13 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so when we're looking, why would I choose over this one with this one? The reason why I would do this one is because I would do multiplication and division on this one. How do you even... Hello, Mari. So is there a more efficient one between the two? The more efficient one between the two, it depends on what the number and what question you're doing, right? So just as I mentioned, I would do the 13 column one because I have more columns to utilize for the bigger numbers. So depending on how big your number gets, it just depends on how you want it. Now, when you talk about efficiency, it just depends if you want to take it everywhere. This is a good size to fit in your pocket. It's not the size of your phone. It's the size of it's kind of like it's the size of my phone, right? That's how small it is. But the 13 column abacus is a little bit bigger. Do you see that? So it just depends on what you're trying to do. Are you trying to just use it as an everyday thing, or do you just want to carry it? Okay, so I wish your $1 trillion was a colorful one too. You know, I was looking at it, and I feel like the 13 column one, if this was colorful, I think it'd be overwhelming because these colors are very bright, and I feel like it'd be very overwhelming to have a lot of brightness in our eyes. So how do you even count with these? Oh wait, hold on. Unless you want to just color your bead. Yeah, you could color your own beads. Sorry, I thought you were comparing with the 2. Oh, no. So this one, the Chinese one, the more modern one is the Japanese abacus now. So we have abacus competitions. There's abacus competitions. When you do abacus competitions, they are focusing on the Japanese abacus. And everybody does the Japanese abacus now. It's just because it's more efficient and you don't need to count up. And what we do is we do formulas, which is what we're going to do. So the 13 one is as big as my tablet? No, it's not as big as my phone. It's a little bit bigger. So if I measure it up, that's how big my phone is. And I think this is a iPhone 12. I have a very old phone, and it's a small one. It's not a Pro. So this is not a Pro. Yeah. Cool. Okay. So how do we count? So let's do a little review for those of you that just came in. Welcome, everybody. Welcome. Thank you so much for coming in and being patient. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Oh yeah, there are abacus competitions, and they are international. So there's a bunch of people. I mean, there's not too many people in America, from America, but there's a lot of Indians and a lot of, I would believe, Japanese, they're very serious about competitions and stuff. And so even the I think the kid that did the world record, I think he was Indian, and he was able to do 100 lines of addition under 30 seconds, which is crazy. It's pretty awesome. Okay, so we know how to move the beads. Oh, we got to do a review. Let's do a review. Thank you for being patient. So we're going to do a review. Here is my abacus. It is a counting tool. This is my counting tool. And what we're going to do is we're going to count on the abacus. Anytime the beads touch this reckoning bar, it's being counted. So when we look, we do 1, 2, 3, 4. And then we have 5. The top bead is 5. We have 6, 7, 8, 9. That's true Americans. 9. So after we have 9, you might be wondering, well, what happens to 9? 10. Well, we want to do 10. Well, after 10, looks like this. That's what 10 looks like. Why is that 10? Because we have our place values. We have our ones, our tens, our hundreds, our thousands, our 10,000s. And that's it. Bada bing. Okay, now we're going to carry on to understanding what? We're going to keep going to understanding why are we going to learn how to make a 5? All right. What are we going to do? We're going to understand why are we going to add a 5? Why did I name it? Plus 5 with who? Because the constant is a 5. What does that mean? The question is 4 plus 4. Here I have 5 cats in a tree. 1, 2, 3, 4, 5. I don't know if you can see that. I have 5 cats in a tree. Why do I have 5 cats in a tree? Because it will help us. They're going to help us. So when we're looking, thank you everybody so much for liking the live. Oh, we're almost at 10,000 likes. Okay, what are we doing? 4 on the abacus. Because we have 4 on the abacus, I want to add another 4. But there's not enough to add the 4. What are we going to do? Well, we have to understand that we have this 5. We have to go to the cats in the tree. There's 5 cats in the tree. If I go to 5 cats in the tree, I grab 4 cats, right? 1 cat runs away. 1 cat runs away. So my final answer is 8. 5, 6, 7, 8. I could show you again with this. If I have 4 pennies, 1, 2, 3, 4. I have 4 pennies. And I want to add another 4. To add another 4, there's not enough. I cannot do this because that would be 44. Why is that? This is 44 because this is 10s, this is 1s. So what's going to happen is what? If I have 4, I want to add another 4. But to add another 4, I'm going to give you my 5 cents. I need change back. Because I need change back, I'm going to take away the 1. So my final answer is 8. 5, 6, 7, 8. I could do it again on my abacus. Add the 5 and take away the 1. And so my final answer is 8. Now, why is this different? It's different because it's a concept. The concept that we're learning is how do you make a 5? We need to remember that 4 plus 1 is equal to 5. 1 plus 4 is equal to 5. This is something that we teach the kids. I'm not sure if you remember this when you were young, but we actually remember this as a fact family. The fact family is being utilized here. So what we're doing is we isolate the variable, we isolate the 4, and we utilize this number. Thank you, Michael, for the follow. Thank you, NC, for the follow. Thank you, in Giza, for the follow. So does that make sense? So we could do it again. And what we're going to do is we're going to practice. We're going to practice this 4. Again, notice that what we're doing is we're looking at our second digit, our second number. This second number, thank you, Chava. Our second number is what? It dictates whether or not, oh, thank you, B. Thank you so much for all the comments and help. I do appreciate it. And I'll see you on my next live. Okay, so we're going to look at, do you teach the metric system on lives? No? Hello, T-Bear. How's it going? It's been a little bit, eh? I don't know, why would I be teaching metric system? I'm just adding, subtracting, multiplying, and dividing. We could, but I don't. Okay, anyways, so the second number is what helps us dictate whether or not we're going to use a formula or not. So if I have 3 on the abacus, 1, 2, 3, 1, 2, 3, I need to add the 5. Why? Because I only have this 5 right here. I need to utilize this 5. To utilize the 5, guess what? That's too much. I need some change back. So what do? I have to minus the 1. So my final answer is 7. 5, 6, 7. I could show you again on my abacus. I can add the 5, but I have to take away the 1. So why? Why do I have to take away the 1? Because I need to balance the equation, right? I can't just add 5 just to add 5. I need to balance the equation. Working too much. But I'm determined to keep learning. Ah, that's great. You taught your husband. That is fantastic. It just takes time. We're here. We're here. So here we are. We're going to do 2 on the abacus, right? We could do it again. And what we're doing is we're focusing on the 4. We're going to understand how to do the 4. So we have 2 on the abacus. I want to add the 4. Again, I don't have enough beads to add the 4. What do? I need to give you this 5 cents. If I give you the 5 cents, that's too much, right? I need change back. So I need to take away the 1. So my final answer is 6. 5, 6. I could do it again on the abacus. Add the 5, take away the 1. And my final answer is 6. Do you recommend me to buy as an upcoming sophomore? What kind of math are you doing? Hello. Welcome back. Hello, O. What kind of math are you? Are you going into algebra, geometry, and pre-calc? Because if you are, then you could buy the abacus. You could buy the abacus, but it would be supplemental. Hey, Jello! How's it going? Dalen, does that make sense? So it depends on what your math is. If you're still doing adding, subtracting, multiplication, division, then I would recommend the abacus. But if you're going to go into algebra, pre-calc, calculus, geometry, math 2, I don't know what math 2 honors means. Does anybody know what math 2 is? I don't know what that means. I mean, do you feel like you're solid in? I don't know. I don't know if it would be for your schooling. I don't know if it would be for your education. I think if you were to buy the abacus, I think it'd just be for your hobby. I think you're at that point where it'd be a hobby. Is it like integrated math? I don't know. I don't know what math 2 is. So it depends on, it could be like a hobby. Oh, here, Jello. So Daylin is a sophomore coming up. Do you think she would be beneficial for her to buy an abacus? Because I know Jello is around that too, right? I don't know. I think it's algebra. Right, Jello? You're a sophomore? I don't know. Freshman? Okay, so as a freshman, do you think abacus helps you in the beginning? See, I don't know. I don't know. So, Dalen, I wonder, are you strong in your arithmetic? Are you strong in adding, subtracting, multiplying, and dividing? Because I think it would be, however, I'm thinking about going to college, which I think would be useful. If you want to, yeah, definitely. It depends on, it also depends on, yeah, so yeah, Jello started young. Oh, Char! Is Char here? The reason why I'm kind of hesitant is because it would be like I never understood how they use that on math. It's base 10 concept. I do think it would help because it would shift your mind a little bit. You know what I mean? Thank you, T-Bear. Get comfortable with thinking about the numbers. I think so. Like, I think it would help, but it would be more like an extra. It would be more like a hobby, and it would get at you exactly what Imeo says, right? Because it would get you to think the numbers differently. Hello, Lisa. Hold on just a minute. Dalen, does that make sense? Polynomials, congruence, similarities, figures, trigonometry, and triangles. Is that what Google says about? Okay. Does that make sense? I mean, I would recommend it, but it would be extra on top of your learning, is what I'm saying. Char has been like, so there are people that are older, but yeah, it helps a lot and it takes a lot of time to get to a level where it becomes useful daily in life. Yeah, I see that. It would be something yeah, it'd be practice. Exactly. It would be on your own time. It wouldn't be part of your exactly. That's what I'm trying to get at. It would be more like a hobby, but it would make you better at math, but it would take time, if that makes sense, Daylin. So it is up to you. It is up to you if you're willing to think of adding and subtracting, multiplying, and division differently. I don't know if that helped. Because like the adults that come in, they would see it as more of a hobby. But see, you're at that middle stage. You're not you're at the middle stage, right? You're in the limbo. So when you should we use the abacus? I would use the abacus because you're still new to it, and I would not worry about having it. I would not worry about going mental. See you later, Jello. I'll see you later. Thanks for dropping by. Even my child, he's done the abacus. He's done the abacus. He gets a little confused. I still say go to the abacus and use it. I would use it as the tool that it is. And if you have arithmetic, use it for what it is. I wouldn't push it to go to mental math, if that makes sense. I don't do mental math. I still use my abacus. I still look at my abacus and I still utilize it for what it is. I hope that makes sense. I'm not Yeah, I hope that makes sense. Okay, so thank you, MBM. Surprisingly, even Sudoku has no calculations, but trains the mind in deduction. Yeah, yeah, yeah. Sudoku, yes, I could see that. But I think as a sophomore in high school, there's already a lot of homework. And I'm afraid that it would overload Daylin. You know what I mean? Because you might be taking AP classes, you might be working a lot more. And if you have extra time to do abacus, then I would. But if you don't have extra time to do abacus, then I would wait till you get out of high school and out of college because you're at that stage where you're going to do a lot of work just going to be doing a lot of work. So, yeah, I mean, I know when my oldest he went to college he went to high school, there was no time for him to do anything extra. He barely did track and he did cross. You know what I mean? So it also depends. Are you doing sports? And if you're going to be doing other extra activities. So this would be really much more of a hobby. It would be good, but maybe later in life. Or if you have time you can sit in on my lives as long as I'm doing lives, you know what I mean, and see if you can pick it up. It is up to you. But I wouldn't stress it to go mental math, and I wouldn't stress. I would still use the abacus for what it is. Okay. So thank you, Dalen. That was a tougher question than I anticipated, because I do worry about your workload in sophomore year. Because freshman, sophomore, and junior year are the toughest. I'm actually going to do my first communion and confirmation. Yeah, yeah. See, that's already and I like do. Yeah, see, all of that stuff right there. If you have time, it would be good. But if you don't have time, I wouldn't stress it. I would wait till you're out of it. Yeah, yeah. Yeah, I was when my boys were young, I was pushing them to try to finish abacus as quickly as possible just because I didn't want it to interfere into any of their sports or any of their academics. You know what I mean? Because it is because but don't forget my kids were young, so they could easily transition from abacus to mainstream math because of the common core. Okay. So let me go back. We're going to do a review. Thank you for being patient. We're going to do a review. Lisa. I don't know if Lisa's still here. True. True. But my example is crossword puzzles is fun, but there is more effective ways to build vocabulary. Yeah, I think so too. Yeah. There's more effective way, but yeah. But see, as the that gap of adolescence, I think is very time. There's a lot of time commitment that I think having extra stuff would not having this would not be prudent. Okay, so for those of you that just joined, thank you so much for being patient. What we're going to do is we're going to review on the abacus. We're going to count 1, 2, 3, 4. Anytime the beads are touching this horizontal bar, this is what's counted. So we have 4 on the abacus, and then if I do this, this is 5. The top bead will always be 5, and then we have 6, 7, 8, and then 9. After 9, we have 10. 10 is a 1 and a 0. We have 11, 12, 13, 14, and then 15. That's how you count on the abacus. So you might be wondering, why am I here? Well, every place value is, every column is a place value. So we have our ones. You'll notice that there's a dot. This is my label. This is my ones, my tens, hundreds, thousands, and 10,000s. Okay, thank you so much, MBM. MBM, thank you so much. Good morning. Thank you so much for helping out. I will see you in my next live. Yeah. Okay, good. So, what are we going to do? We're going to continue on, right? Let's do, we're still doing this. So we have 3. When we add the 3, that's what we're going to do. We have to pay attention to whether or not we need to use the abacus, whether or not we're going to use the formula. Now, if we look, we have 1, and we want to add the 3. To add the 3, is there enough to add the 3? Yes, there is. We can add the 3. That means we don't need to use the formula. So we don't need to overextend ourselves. We just need to add the 3. 1, 2, 3. So my final answer is 4. Oops, 4. So we do it again. We can do the 3 again. If we do the 3 again, let's see. If I have 2 on the abacus, I want to add 3. To add the 3, 1, 2, I want to add the 3, but I can't. Guess what? I have my 5 cents. That's more than enough, but that's too much. I need to take away 2. Why? Because I give you 5 cents, I need change back. So I could do it again on my abacus. I can add the 5, take away the 2. So my final answer is 5. And then I could do it again. So what we're doing is we're practicing how to add the 3. We're adding the 3 because that's our second number. We isolate the variable, we isolate it, and we have our formula. So we have 3 on the abacus, 1, 2, 3, right? 1, 2, 3. And then we have 5. Because we want to add the 3, but that's too much. I got to take away 2. So my final answer is 6. 5, 6. So I can do it again on the abacus. I can add the 5, take away the 2. Here is another way. Here is another way. I think you miss my fingers. Okay, so let's do it again. So we have 3 on the abacus. 1, 2, 3. 1, 2, 3. And then if you notice, I want to add another 3. To add another 3, 1, 2, 3, right? 3 on the abacus, 3 here. But guess what? I want to add another 3. This is the 3 I want to add. So what do? We are going to use this package. This package has 5, right? Inside, 1, 2, 3, 4, 5. Inside, I'm going to use only these 3 beads. These 3 cubes. The only cubes I'm going to use is this one. I need to take away this 2. So I'm going to add the 5, right? But I got to take away this 2. But it's too hard to take away the 2 here. What we're going to do is what? We're going to take away the 2 from this loose beads. That's it. So I take away the 2 from here. So my final answer is 6. That's it. Does that make sense? So we had to balance the equation. We could do it again with the 4. So we have 4. 1, 2, 3, and then 4. Right? 1, 2, 3, 4. I want to have 4 on the abacus. That's it. 4. Oh, the cube did. Yeah, right? I know. It was amazing. Thank you so much, T-Bear. Yeah, there was a lot. I was like, I was really thinking about this. Like, how is it going to be? So again, I've had four. 1, 2, 3, 4. I want to add 3, but I only have this package. This package is taped. It's too much work to take it apart. 3 is right here. 1, 2, 3, 4, 5. 3 is right here. 1, 2, 3. Right? This is the beads I don't need. But guess what? They're stuck together. But I need to remove it from here. 1, 2. So I can do that. So I add the 5 and I take away the 2. So my final answer is 7. 5, 6, 7. Yeah. Wait till I go to plus 10s. That's going to be awesome. So good. Wait till I do plus 10s. It's going to be so awesome. It was so cool. Yes, thank you, T-Bear. I don't know what your name is. What is your name? Is that a G? GC? Take notes. Take notes. Voices by Ruben. Thank you so much. So, I mean, and when you look, it's just going to be the same thing with the 2. So here, right, why are we doing with the 2? The reason why is because we have a set. 1, 4, 4, 1, 3, 2, 2, 3. This is the set. This set is how we make the 5. So we know that every time we need to add the 2, we can utilize the 5. So here, if I have 4 on the abacus, 1, 2, 3, 4 on the abacus, right? I do it again. I want to add 2. These are the 2 beads I need to use. But what happens? These 3 I don't need. I just need to throw it away, but I don't want to cut it. I can take it away from here. 1, 2, 3. I can add the 5, right? That's what I did. Add the 5, but I need to cut it. But to cut it, I can't. So what do? I have to take away these 3 beads. So what do? Take away these 3 beads. And my final answer is 6. 5, 6. Right? And so if you notice, the formula is plus the 2 is equal to plus the 5 minus 3. Plus the 5, right? Adding the 5, and then we have to take away the 3. So these are now instructions how to add the 2. And then we could do it again, right? We have instructions. We want to plus the 3. Plus the 3. There we go. Plus the 3. What do we want to do? We want to add the 2. Add the 2. The formula, the instruction is plus the 5 minus the 2. Oh, yeah. I need that one. So then my final answer is what? Oh, 3. Because I have 3 on the abacus. I want to take away, add the 5, take away the 3. That's what I want to do. And my final answer is 5. Yep. Yep. Thank you, Voice by Ruben. Thank you so much. Thank you so much for you're awesome. Thank you so much. Okay, right? So when we're looking, we could do it again with the 1. But the problem with the 1 is they're only the 1. Why? Because if I do 1 plus 1, yeah, you could do it. Not a problem. If I do this one, 2 plus 1, I could do it, right? I have this 1. I could do it again. 3 plus 1. Yep, I could do it. But guess what? This is where I need it. This is where I need it. 4. 4 plus 1. 1, 2, 3, 4. Guess what? I have my package, but I only need this 1 cube. But I have to get rid of all of these. To do that, I need to get rid of all of these. So my final answer is 5. That's how I get 5. 5. There we are. Awesome. Okay, how are we doing? Yeah? So, now we're to 1. Okay, so this is my book. This book is all about how to make a 5. What we're trying to do is understand when we add 2, 1, 2, 3, 4, and there's more than 5, right? So that's what we do here is we practice how to utilize the 5. And so we have color by number, we have mazes, there's word problems, there's hidden words, color by number, more color by number. There's also tic-tac-toe, right? Tic-tac-toe is you find the answer, then you put your marker down, and then you put your answer. And then you try to get 3 in a row. And then we have some dice, number bonds. What else? I think that's it. Yep, these are all just activities. All extra activities to practice how to make a 5. And then afterwards, if you're unsure, I do have answers in the back of the book. Okay, so what's next? So we did the plus 5. Hello, everybody. Welcome, everybody. Welcome. Thank you so much for joining. It is... How are we doing? We are going to do a little review on the abacus. Let's do a review. So we have 1, 2. Notice that anytime the beads are touching this reckoning bar, this is what's counted. So this is 2, this is 3, 4, and then 5. The top bead is always 5. And then we have 6, 7, 8, 9, and then 10. That's what 10 looks like. Thank you, Scar, for the follow. Thank you so much for the follow. I appreciate that. Do you have any questions, Scar? So when we're looking, we have 10. Why are we here? The reason why, because I have this dot. This dot is my ones indicator. Because I have my ones indicator, right? This is my ones. So just as we have here, we have ones, tens, hundreds, thousands, 10,000s. So we can count 1. This is 100. We have 1,000. And then we have 10,000. That's it. Okay. So what's next? We're going to do plus 10s. How are we doing? For those of you that just joined, how are we doing? Anybody want to ask some questions? Any questions about the abacus? Okay, you know what? Here, let's do this. Let's do this. Thank you for the follow. Thank you for the follow. Okay. Oh, see, that doesn't work. Okay, yeah. What number... Here we go. What number do you think this is? So on my abacus, I have... Let's see. There we go. What number do we think that is? We have our thousands, our hundreds, our tens, and our ones. Hey, Melinda! Thank you, Poetic. Hello! How's it been, Melinda? It's been a little bit. What number do we think this is? How do we know that this is the number? Thank you, Poetic. Thank you, Poetic. Okay, so for those of you that are just joining, we have our thousands. We have our thousands. Things have been wild. Thank you. Yes, it is. 1,000. Whoa, 1,000. No, it's not 1,000. 1,000. 1,000 looks like this. 1,221. But it's a 5. Alistair and C. This is 5. Right? So we have to remember that the top bead is a value of 5. And then the bottom bead's a value of 1. So 1, 2, 2, that's what that would look like. So the next number was this one. So we have 3,000. Yes, thank you, Melinda. We have 3,294. Yep. 94. 3,294. I've been well. I've been out camping for a little bit. You right. I had to do a double take. Yeah, I was on vacation for about 10 days, and then we went fishing for another 3 days, and my viewers are starting to come up a little bit. So I've been hovering around about 100 people coming in and out of my out of my lives, which is really crazy. And I'm thinking about going live a little bit more often. Oh, that's right. And then I finished my book for, where is it? I finished my book for adults. I haven't put it on my TikTok shop yet, but it will be. I haven't done it yet, but it will be. Yeah. So I'm excited. Yeah, I am expanding. That's cool. Thank you so much, Melinda. Yeah. Yeah, crazy, right? So, okay, what are we doing? Okay. Thank you so much. Okay, how are we doing? It only seems like the 2 people are answering. So, what do you guys want to talk about? How are we doing? Poetic, do we want to continue on? Oh, is T-Bear still here? We can do some adding of, making of the 10. Do we want to make a 10? Or do we want to continue on making the 5? Or do we want to minus the 5? Yeah, I'm on my 15th book. Crazy. And now, oh, that was the thing. So I was going to do I got to do the 2-step and then the 10s, please. Okay, make it 10. Okay, let's make it 10. Thank you, NC, for commenting. You guys are so quiet. If you guys are quiet, I don't know you're here. Okay, this is going to be awesome. This is going to be awesome. Oh, yeah. Melinda, I came across like how to make a 10 much better to explain. All right, how to make a 10. What are we doing? We have to remember. Thank you, NC. Yeah. Okay. So we're going to understand what? We need to understand our pairs, our fact families. Just like we have a fact family of 5, we have a fact family to make it 10. 5 plus 5, 8 plus 2, 3 plus 7, 4 plus 6, and 1 plus 9. We need to understand that these are our pairs. The same concept, but different numbers. So everyone will get a voice soon. Oh, okay. So what are we doing? Let's do 8. We're going to do 8 plus 8. Now remember, we're not going to memorize our doubles. What we're going to do is we're going to utilize concepts. We understand that 8 plus 8, right? 8 on the abacus. We have 8 on the abacus. And then we want to add another 8. Well, guess what? We have to do something with the 10 and the 2. 10 and the 2, what does that mean? Well, we're going to carry over. The 10 is carrying over. That means we're going to add the 10. That's carrying over. And then we need to minus the 2 because adding the 10 is too much and we need to take away the 2. So my final answer is 16. All right. That was a little complicated. Okay. That's fine. Let's do this. Let's do this. Here is 8. 5, 6, 7, 8. Right? On my abacus, I have 8. Right? Now, thank you, Melinda. Now, what we want to do is we want to add another 8. I'm going to add another 8, right? That's what I'm going to do. But remember when we add 8, we know how to make a 10. We need 2. Where are we going to get the 2 from? We have to get the 2 from here, from the previous 8. So guess what? I'm going to take the 2 from here. I take the 2 from here, and I add it to here. So when I add it, now I have 10. And I need to show it on my abacus. Add the 10. And that's it. Hello, Easy Money. Thank you so much for the follow. So what did I just do? I rearranged. That's what I did. So I took the 2 away from here. Right? So now this is 10. What do I have? 5, 6. So we have 6 and then we have 10. That's all I did is I just rearranged it. 1 and then 6. 5, 6. We can do it again with the 7. We do it again with the 7. Right? There's a 7 here. I have 8 here. So when I have 7 on the abacus, I have 7 on the abacus. I have 7 on the abacus. Right? 7 on the abacus. Because I'm doing this number, right? I'm doing 7 plus 8. So I have 7 on the abacus. 1, 2, 3, 5, 6, 7. 5, 6, 7. I want to add an 8. To add the 8, I already did this. But guess what? I know how to add and make a 2. Make a 10. If I'm going to make a 10, I got to get it from somewhere. I got to get it from the 7. So I got to take it from the 7 and I'm going to make a 10 out of it. So I take it away from the 7 and I make a 10 out of it. So if you notice, my final answer is 15. That's what I did on the abacus. Add the 1, add the 10, and that becomes 15. Yeah. Cool. So what are we doing? We're understanding that we need to take away the 2. We have to take away the 2 from the 7. So we could do it again with the 4. Let's do 4. 1, 2, 3, 4. We want to add 8. Right? We have 4 on the abacus. Right? 1, 2, 3, 4. 1, 2, 3, 4. Add the 8. To add the 8, guess what? 1, 2, 5, 6, 7, 8. I know that I need a 2. So what I'm going to do, I'm going to take it away from the 2. I'm going to take it away from the 4. Take it away from the 4, and I'm going to put it with the 8. So now I have 10. Now I have 10. Okay. Can you teach my kids? Yes, I can. Kat, if you want to DM me, the hardest thing for, I'm sorry, Kate, if you want to DM me, we can talk about it. But I do offer teaching. I do offer teaching math. Yes. Okay, I think the hardest thing for me is to remember is to move the 10 to the left, not the right. Questions? Or is it confusing to say? I don't understand the box, but I'm... Okay, hold on, easy money. So, however, and see, when we're looking at... It cannot be to the right. It cannot be to the right because when we write 10, it's to the left. So if we have 9, why would we do that? Why would we do that? You know what I mean, NC? So it's not to the, it needs to be to the right, not to the left. Wait, move the 10 to the left. Yes. Right, you know what I mean? Thank you, Alistair. Yeah. So when we're doing 9 and 10, right? So that would be it. So when we do 19, right? We do 18. It's still to the left. This is the tens. Okay. Hold on, easy money. What's your question, Melinda? No, it won't be confusing to say anything. Come on. What's your question, Melinda? Let me know. I want to know. Thank you, everybody, for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Thank you, Alistair. Oh, don't have questions, just encouraging others. Yes, yes. If you're confused, please comment. Thank you, Alistair. Yes, thank you for opening your mind. Thank you. Welcome, everybody.
Welcome to the real world.
Okay, easy money. We're back to you. This is the box. Show the place values. Yes, yes. I could see simple money. I'm just curious. Yes, we could do it. Why do you use this? I use this because it's the greatest thing next to sliced bread. Thank you, Easy Money, for your patience. So what we're going to do is we're going to read this column. So this is an abacus. An abacus is, it's not really a, is it a box? It's a frame. It's not a frame. Is it a box? It could be a box. Yeah, I guess so. So when we're looking, right? Oh, you have to see it. You can't see it. There we go. There we go. There we go. Okay. When we're looking, these are beads. All the bottom beads are movable. These are all very movable. If you notice, they are moving, right? So when we look, we're going to count 1, 2, 3, 4. Because this is 4, why do we know this is 4? This is 4 because this is the reckoning bar. This is the horizontal bar. Because it's the horizontal bar, it tracks our numbers. Because it tracks our numbers, 1, 2, 3, 4. This is not touching the reckoning bar, so it's not counted. So then we have 5. That's what 5 is. 5 will always be the top bead. We have 5, 5, 5, 5, 5, 5, 5. Then we have 5 plus 1. 5 plus 1 is 6. We know this is 6 because this is 1. We add the 5, now we have 6. We have 2 plus the 5, now we have 7. We have 3. 1, 2, 3. 1, 2, 3. We add the 5, now we have 8. I'm coming back. Oh, okay. Okay. Why do you use, I don't know, why am I using the abacus? Because it's the greatest thing next to sliced bread. Okay, so you want, so we're ready for multiplication. Is there any other questions about making a 10? Because we can continue on with making it a 10. I'm intrigued. Oh, thank you, Expo. Hey, Daylin, welcome back. I just did how to make a 10. You want to see? Let me show you the way. Let me show you the way.
This is the way.
This is the way. This is the way.
Okay, so what are we doing? We're going to do the 9. We have a 9. I want to add the 7. Oh, let me do 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? We want to add 7. We know how to add 7. Okay, but in mainstream math, you count up. But in abacus, we don't. We're going to make a 10. How do we make a 10 with 7? We know 7 plus 3 is equal to 10. We know 7 plus 3 is equal to 10. 7, right? 5, 6, 7. We know we need to get 3. But guess what? Where are we going to get the 3 from? We're going to get the 3 from the 9. So we got to take away the 3. So we take away the 3, and I got to add it to the 7. Now I made a 10. Because I made a 10, I could show it on my abacus. So we did is minus the 3 plus the 10. I can't wait. I've achieved learning abacus. I could do it with my fingers. And that's funny. Dalen, did that make sense? So what we just did is we're utilizing the how to add the 7. So adding the 7, we need to plus the 10 minus the 3. So what did we do? We plus the 10 and we had to take away the 3. So what I did was I had to take it away from the 9. Oh, so then this is my 10, right? 5, 6, 7, 8, 9, 10. This is my 10. And then what do I have here? I have 6. 5, 6. So I have 10 plus 6 is equal to 16. Right? And then we could do it again. So if I have 18 on the abacus, I have 18 on the abacus, 1, 8. And I want to add the 7. Oh, I can't add the 7. I want to add the 7. Add the 7, what do? Plus the 10 minus the 3. And my final answer is 25. Right? So this is the formula. The formula is plus the 7 is equal to plus the 10 minus the 3. And we could do it again. Every one of these is, do I do online? I do, Jen. If you want to DM me, we can talk about it. I don't know if is there a service link at the bottom? I'm not sure. But yeah, I do online tutoring. Abacus only though. Just so you know. I only do abacus. Yeah. Oh, I already blocked Justin Miller. Thank you, NC, though. I did block Justin Miller. Okay. Let's see. Just checking to see what you see. Do you see what I see? Okay. I guess I don't have a service link. Oh, I do. There's a service button at the bottom. You can take a look at that. You can send me a message at the service link. Where are you from, teacher? I am from Los Angeles. Easy money. Okay, so what are we doing? We could do it again. So we do 14 on the abacus. We do 14 on the abacus. We do 1 and then 4. And then we're going to add the 7. To add the 7, we need to use the formula. So the formula is plus the 10 minus the 3. That's why we're doing it. Because if we do 14 on the abacus, right, and I want to have 7, 14 on the 14 on the abacus. This is 14, right? This is 10 and then 4, and then we want to add 7. So we have 6, 1, 2, 3, 4, 5, 6. So guess what? Because I have 7 right here, I need to make it into 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got to take it away from here. I have to take it away from here. 1, 2, 3. Take it away from here. And then what do? I am left with 20, right? 21. Okay. Okay. Have a good night, Easy Money. Have a good night. I will see you in my next live. That's what it is, 21. So what did we do? We just organized it and rearranged it. I wish you were my teacher growing up. Oh, I'm 36. I want to learn new math tool. Yes, you can. Okay, good night. Good night. Good night. Thank you guys for joining. Thank you for joining. And I will see you all in my next live. I'll probably be here tomorrow morning. I'm trying to be here 8 o'clock. No, cannot do 8 o'clock. I have office hours. I also need to say, okay, Melinda. I love seeing you too, Melinda. It's so nice to see you. I'll see you in my next live. I hope to see you soon. Be safe, Melinda. Be safe. All right. How are we doing? So what we just did is we added the 10. That's what adding the 10 is. What's my time zone? Pacific Standard Time. I'm in LA. I'm in LA! And we're doing a tsunami watch. So far, so good. So far, so good. We don't have any tsunamis. But I think it hit Hawaii pretty hard. But yeah, our beach is closed because we were doing a tsunami watch. How are we doing? Okay, we're going to do it again. So we're going to do the 9. Yeah, crazy. Yeah, doing good. Yeah. Yeah, so far so good. I don't think we've heard anything coming from the tsunami. So I think it dissipated, but I think we're still going to be on watch for another two days. I'm not sure. I gotta keep up with the news. But yeah. Why do you want to know what my ethnicity is? Same. But that is a better question than most questions that came here. I have family in Canada. I'm in Idaho. I am Chinese. Thank you, Fanta. Yeah. Okay. So, very new. Oh, okay. So you're new. Okay. Thank you for letting me know, Fanta. I understand a bit of Chinese. Oh, yeah. What kind of Chinese do you know? Do you know Mandarin or do you know Cantonese? Do. Yeah, I'm Cantonese, but my kids they're learning Mandarin. Oh, sorry. Excuse me. Okay. New. So we're gonna count 1, 2, 3, 4. Okay. Whenever the beads are touching the horizontal bar, that's what's counted. So this is counted. This is 4. None of these are counted. So what we're doing is we're just checking to see what the number is. We have 5. That's what 5 is. Slate. Thank you. I appreciate that you're here for just pure entertainment. Oh, thank you so much. What are we doing? What is this? What's going on? Oh, I got 100 more gems. Okay, thank you guys. Thank you. Thank you. I appreciate that you're interested. So yeah, this is 5. This is a value of 5. That's all it is. Value of 5. And then we have 6, 5, 6, 5, 6, and then 7, 5, 6, 7. This is 8, 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. And then you might be wondering what's 10? 10 is a 1 and a 0, just like how we write 1 and a 0. How do I know this? I know this because it's magic. No, it's not. No, it's not. It's so easy. So easy. So if you look, there's a dot right here. That dot is my ones indicator. So we have our ones, our tens, our hundreds, our thousands, our 10,000s. We have 1. This is 10. This is 100. 100. This is 1,000. 1000. And then we have 10,000. 10000. So when I only took a year and a half of Mandarin. Oh yeah. Alchemy. Some people has called me a witch. But it's all in fun. I understand. It's funny. Oh, thank you so much for the rose. Thank you so much for the rose. I appreciate that. For those of you that are interested, go ahead and check in at the orange heart me by my forehead. There we go. Just touch my forehead. Thank you guys for joining. Thank you guys for joining. Thank you so much for sharing my live and liking my live. All right. Yeah, I don't know Mandarin. I wish I did, but I don't. I don't speak that much Chinese. I can't speak Chinese. I don't even know conversational Chinese. Yeah. Yeah. I grew up in Canada and we didn't have time to go to oh, thank you so much for the donut. Thank you so much for the donut and the summer. Oh, look at that. Thank you so much. Um, yeah, it was one of those things like back in the day, it was just hard. And I didn't go to places where was a lot of Chinese people. I was around a lot of other people. And so, oh, hey, Jeffers! Thank you so much for the tiny tiny. Welcome, welcome, Jeffers. I was just talking about how to make a 10. Did I show you my new way of making a 10? Did I show you? It was kind of cool. Did I show? I don't know if I showed you. So here's 9. We'll do 9. No, I think I did. 9. Okay, we have 9 on the abacus, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. All right, 9. So we have 9 on the abacus. We have 9, right? And then we're going to add 7. To add the 7, we have 5, 6, 7. Thank you so much for liking the live. Thank you for the follow, Teresa. So we have 7, right? We know what? We know that 7 plus 3 is equal to 10. We got to get the 3. The 3 has to come from somewhere. So here's my 7. The 3, we need to 3. We need to do 1, 2, 3. 1, 2, 3. But we need to get it from somewhere. We need to get it from the 9. So I'm going to take the 9. I'm going to take 3 away from the 9. So I take the 3 away from the 9. Guess what? Now I have 10. Because I have 10, I could show you. Plus the 10. So my final answer is 16. So when you bring it all together, we're just rearranging. So we have 16 now. There we go. There we go. There we go. There we go. Did that make sense? I like it. Oh, you like it? Oh, good. Thank you. Thank you. Thank you. Thank you. Yeah, it took a while, right? But I mean, you already know. You already know. But it was one of those things like, how do I explain it to those people that don't know? And then I talked about another one, which is, it was a package. So if we do 4 on the abacus, and I want to add the 5, that helped the kids with it. Yeah, exactly, on the top of the head. Yeah, right? So if you have 4 on the abacus, I want to add another 4, but I have this package. This package is taped, right? And I need to use 4. 1, 2, 3, 4. So if I'm using these 4 cubes, I need to take away this 1, but I can't because it's all stuck. Because it's all stuck, I have to take it away from this 4. So my final answer is 8. That's another way. But this one, I don't know if this would, that might help too for the kids, you know, if they're understanding what the 5 is. So you take the 4, 1, 2, 3, 4, and then we have to move this, but we can't. Yeah. Yeah, I think so. I think so. Thank you so much for the friendship, Sikai. Okay, how are we doing? Welcome, welcome, welcome. Hello, everybody. Thank you so much for joining. Thank you so much for joining. What we were doing, I've been letting my nieces, and nephew play with my abacus. They're little. Oh, I love it when they're little. Ah. Yeah, that's good. Just let them play with it for a little bit. And it doesn't matter what place values. So when I was teaching this 3-year-old, I would tell them, show me what 1 is. 1, 1, 1, 1, 1, 1, 1. I would let them to do all of it 1, just to get them the idea. You know what I mean? Yeah. It'll be fun. It'll be fun. But yeah, it'll be crazy. Okay. How are we doing? Daylin, are you okay? Any questions about how to make a 10? We can continue on. So here is a color by number activity. And we did it here. My nephew likes testing me by... Oh, yeah! Can you do one more? Yeah, we'll do one more. I'm sure he's going to stump me. So, can you see that? Okay, what are we going to do? We want to add the 9. We're adding the 9, right? I want to add the 9. I want to add another 9. To add another 9, what do? We know 9 plus 1 is equal to 10. So I have 9 on the abacus, right? 9 on the abacus. I want to add another 9, right? We add another 9. But instead of mixing it all up, what do? We know to make a 10, it's plus 1, right? We know we need to add 1. But where are we going to get the 1 from? We got to get it from the previous 9. So we add it from here. We take away the 1, and make a 10. We take away the 1 and make a 10. I like that. And then what do? We have to take away the 4. Take away the 4. We know how to take away the 4. Minus the 4 is minus the 5 plus the 1. Because if we know how to add the 5, we know how to subtract the 5. And that's a different book. Oh, what book are we doing right now? We are doing the plus 10 book. Excuse me, plus 10. What are we doing? Where is it? Plus 10. Plus 10. That's the book we're on. So, we have, thank you for the follow, Diamond Rider. So we had 9 plus 9 is equal to plus 10 minus 1. And then this one right here is minus the 4 is equal to minus the 5 plus the 1. So those are the two formulas that we did. And then we can do another one. Oh, unless we want to do this one. Here we go. Let's do 6. 6 is plus the 10 is equal, plus the 6 is equal to plus the 10 minus the 4. Why? Because we know that 4 plus 6 is equal to 10. So if I have my question, 9. So we have 9 on the abacus. We have 9 on the abacus. Oh, there we go. 9 on the abacus. 1, 5, 6, 7, 8, 9. And I want to take away, I want to add the 6. I don't have any more beads to add the 6. But what do I have to do? I have to take away the 4 to make a 10. So that's what my answer is. So my final answer is 15. That's great. I have to take away the 4 to make a 10. That's a brilliant. I like that. I like that. So then we could do it again with the 5. Right? 5 is 5 plus 5. 5 plus 5 is equal to 10. And so what are we going to do? We're going to add the 5. To add the 5, we have to minus the 10 plus the minus the 5. Plus the 10 minus the 5. So here's my question, right? My question is what? 9. I have 9 on the abacus. Guess what? I need to plus the 5. That's what here. I want to plus the 5. To plus the 5, I need to minus the 5 plus the 10. So I'm going to take away the 5, and I'm going to plus the 10. My final answer is 14. 14. Thank you, Dalen. How are we doing? Thank you guys so much for liking the lives and the follow. Okay, what we're doing is we're understanding how to make a 10. So for those of you that are interested, that's what we're doing. We're doing making of a 10. And then I do sell the abacus available in my TikTok shop. This is a plastic abacus. This is a 7-column abacus. 1, 2, 3, 4, 5, 6, 7. It's got 2 labels, one for the tens and one for the ones and one for the thousands. What else? They're easy to move, and if you notice, they're easy to move. You'll just use the edge of the beads to move the beads. Yep. And when we're looking, we don't want to be aggressive. Don't be aggressive, because if you're aggressive, you're going to get the wrong answer. You're going to hold the abacus, and you can do calculations with your right hand. Yep. So this is 0. Because this is 0, hello, Phoenix. So because this is 0, we can count. We're going to count 1. Anytime the beads are touching this reckoning bar, this is what's counted. We have 1, 2, 3, 4. 1, 2, 3, 4. This is all 4. 4 is touching this horizontal bar, this reckoning bar. Then after 4 is 5. 5 is always going to be the top bead. So we have 5, 5, 5, 5, 5, 5, 5. These are all 5s. Because all of these beads are touching the reckoning bar, these are all counted. And then we have 6. So we have 5 and then 6. And then 5. And then we have 7. So we have 5, 7, 5, 6. Right? 5, 6, 7. That's what 7 looks like. And then this is 5. We have 8. How do I know? 5. Right? 5, 5, 5, 5, 8. Why? Because there's 3 here. 3 plus 5 is 8. And then we have 5 and 5. We have 9. 5 plus 4 is 9. So we have 5, 1, 2, 3, 4. We have 5, 5, 5, 5, and then 9. Because why? Because these beads are touching this reckoning bar. These are counted. None of these are touching the reckoning bar, so these are not counted. This one's counted because these are touching the reckoning bar. So we have 9. Cleared my abacus, now we're at 0 again. When we do 9, then 10 looks like this. 1, 0. 1, 0. That's what 10 looks like. 0. Because why? 0 is a placeholder. Excuse me. 0 is a placeholder. This is 10. We have 10, that's 11. After 11 is 12, is 1,000, right? Sorry. Let me do that again. 1, 10, 100, 100, 100, 1,000, and then 10,000. Mikey! That would confuse me. This confuses you? This is 1? Is that confusing? Okay, Mikey, you're going to have to comment. Okay. Because Mikey commented. I'm not picking on you. It's just you're the only one commenting. There we go. Like that? Because the 10s, the 100s, and plus. Oh, you know? Oh, okay. I see. Yeah. So, you're the only one commenting. No, thank you. Thank you for commenting. Now I know I'm not the only one here. All right, good. So when we look, right, every column is a place value. So we have ones, tens, hundreds, thousands, and then 10,000s. And it makes it right, and it doesn't matter what column we're at. So you might be wondering, here's a question, right? You might be wondering, well, why am I here? Why not over here? You'll see that there's a dot. This dot is a label. This label tells me the ones place. Hello, Emily. Hello, Emily. That's my label. My label is my ones place. This is my ones, tens, 100,000, 10,000. This right here, if you notice, is my thousands. Because this is my thousands, I have a label. I don't need to count it, right? I don't need to be like, okay, ones, tens, thousands, hundreds. Because I have this, I know that this is thousands. So this is the grouping of my commas, right? When we talk about numbers. So when we talk about numbers, we have, let's say, I don't know, 4,000, 321, right? So when we're looking, we have 4,321. Does that make sense? So this is my comma. But you know, however, I was going to ask that. Oh, feisty. Good. I'm so happy you're commenting too. Thank you, Emily. So like a Pokemon, right? You got to choose one. You could choose this one.
Pokemon, I choose you!
You could choose this one to be your ones place. So then what happens? You would move everything over and it would look like that. So we have our ones and our tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have, 10, 20, 30, 40, 50, 60, 70, 80, 90. But then what happens is we have no more room for hundreds. But it's okay. Because if we were to talk about decimal places, let me see my decimal place. If we talk about decimal places, there we go. We can have, this is still my ones. This is 90.00001. That's what it would be. Can you do 5 plus 5 again? I was confused when you got to 14. And then you finished this explanation. Yes, I will explain 5 plus 5. Right? So, but you might be wondering, well, what happens when I have a bigger number like this? I don't have that many beads, right? This is my ones. This is my 5, right? So when we look, this is 5. Oh, no, that's wrong. This 5,123. Point 25. 2, 5. Tenths and then hundreds. So then you might be wondering about this. This is 6 and then this is 7. 7, 6, 7, 6, 5. Nope. 5. This is 5. This is 6. Oh, yeah, 65. So we're going to do 65,123.25. And then what are we going to do? Well, we need these two numbers. Can't do it here. You're going to have to use a bigger abacus because size matters. So if this is my ones, I could do 3, 2, 1, 5, right? I still have my dot. This is my thousands. I have 6, 7, 9. So now I have millions. There we go. So 65,000, right? 123.25. Every column is a place value. Every column is a place value. Yeah. Yeah. So every column is a place value, and that's all it is. The abacus is just a way to see your numbers. That's all it is. So if you look, if I choose this one to be my Pokemon, if this is my ones over here,
Okay, Charizard, I choose you!
then I do ones, thousands, millions, billions, and then trillions. I thought the top beat is always 5. Ah, there's a bigger one. I was wondering. Yeah, the top is always 5. It doesn't matter. 5, 5, 5, 5, 5, 5, 5, 5, 5. Yes, the top is always 5. So how does it make it 2? 2 is this. That's 2. $25. That's what I did. 25. 3, 1, 2, 3, 2, 1, 2, 1, 5, 6, 7, 9. Oh, Heidi, welcome back. I thought the top one was down. No, the top one's not down. You know, but that's what I'm saying. Because I move my abacus, the beads are so quick. The beads are so easy to move, you're going to get the wrong answer. See? So that's why you use your left hand to stabilize the abacus. Good, Heidi. I'm so happy. So when we're looking, that's, you know, and I use the colorful one just because it's just prettier. That's all. There's the only difference between these two is that their color. Yeah, no. The color means nothing. The color means nothing. What matters is the positioning of the beads and the size of the abacus, right? This is 13 columns. This one is a 13 column. This is only 7. So depending on, you know, you can only do up to 10,000. This one you can go up to trillions. Yeah. So when we're looking at it, what we do is we're visualizing colors for decoration. Yes, exactly, Feisty. Oh, 5 plus 5. Okay, 5 plus 5. So we have our number. 5 plus 5 is equal to 10. We're going to do 9. 1, 2, 3, 4, and then 5. And then we want to add another 5. Right? That's the question. 9 plus 5. 9, 5, 6, 7, 8, 9. 9. Right? And I want to add the 5. To add the 5, we know what? We know 5 plus another 5 gives me 10. 5 plus 5 is equal to 10. Does that make sense, NC? So when I add this, what am I going to do? I'm going to take the 5 away from the 9. That's it. Take the 5 away from the 9, and I'm going to add it to here. I've made my 10. Because I make my 10, I can add it. So my final answer is 14. The color... Hey, copper! Color actually helps me see where the... yeah. For people who don't know what dyscalculia is, the disability to process math. Oh, okay, I missed the number. So I thought the question was not... I'm sorry. I thought the question was 5 plus 5, not the formula. Oh, yeah. So the formula is plus the 5 is equal to plus the 10 minus the 5. So that's the one. That's the thing, right? To understand the formula. That's the formula we would have to memorize. You have to memorize plus the 10 minus the 5. But I'm showing you why. I'm showing you why it's plus the 5 because you need to take away from the previous number. So this is my 9, and I want to take away the 5. Why am I taking away the 5 from the 9? Because I want to make this 5 a 10. To do that, I got to do this. I got to take it away. Oh, yeah. And now I make a 10. Yeah, no. I love this. This is great. I minus this 5 to make a 10 down here. It just takes longer for you to process everything. Oh, yeah, Heidi. That's okay. Everybody takes time, right? And don't forget, this is also very unfamiliar. This is unfamiliar. This is unfamiliar ground. Thank you for joining, Heidi. I do appreciate you here. Yes. But it's interesting. I think one of the things is that you can visualize the numbers. So this is 9. We have our number, right? We have 1, 2, 3, 4. And then we have 5. The top beat is 5. After 5, we have 6, 7, 8, 9, and then 10. 10 looks like that. That's what 10 looks like. So when we're looking, we have 10. We have our ones, tens, hundreds, thousands, and 10,000s. So you might be wondering, there's a dot. This dot tells me this ones place. I don't know if that's where you were. I don't know if that's when you came in when I talked about my dot. This dot is my label, and this label tells me the ones place. Because I have my ones place, right? Then this will be my thousands. Now I have groupings. I have dots to tell me my groupings. So this is my ones and my thousands. And then I can count 10. So we have 1, 10, 100, 100. We have 1,000, 1000. And then we have 10,000, 10, 10000, because my ones place is over here. Yeah. Yeah. How are we doing? Make sense? Thank you so much for liking the live. We're at 16,000. 16,000. What does 16,000 look like? 16,000. 16,000. So 16, 1, 6, 0, 0, 0. Thank you so much. Okay. Any more questions? We can continue on with making of a 5. I'm not making a 5, making the 10. Or do you want to go, Heidi, do you know how to make a 5? We can go back a little bit. So this is making of the 10. And I thought that was kind of cool, right? And then what are we going to do is we can make a 5. Why are we going to make a 5? We're going to make a 5 because we need to utilize the 5. So that's what this is. So my next book, wait, what is, oh, Jeremiah. Okay, hold on. Let me show you. Let me show you the way. This is the way.
This is the way.
This is the way. This is the way.
Okay, NC, I'll see you later. Thank you so much for dropping by. I do appreciate you coming by. I'll see you in my next live. See you in my next live. Okay, what are we doing? Oh, we got to do that. This is the the only way. Jeremiah. So we do 2, 1, 2, 3 times that by 2, 1, 2, 3. Guess what? We got to count our numbers. We got to do 1, 2, 3, 4, 5, 6, 7, 8. So we know our place value is going to be 8. Place value, 8. We're going to use my bigger abacus. So what are we going to do? I'm going to call this my ones place, right? 1, 2, 3, 4, 5, 6, 7, 8. So we're going to be here. My answer is going to be here. Because size matters. Thank you, Eve. Size matters. So I'm over here, right? So what are we going to do? We're going to do 2 times 2. 2 times 2 is equal to 4. 4 is a single digit, so I got to make it a double digit. So 0, 4. So what's my answer? My answer is 4 million. Ones, thousands, millions. So my final answer is 4 million. Does that make sense, Jeremiah? That's it. How you doing, Eve? Welcome back. Yeah. That was a good question. Thank you so much. Thank you so much. Thank you so much. I'll be here all night. All right. So. Uh-oh. Error for me. Oh. What? Oh, because you don't know multiplication. Hold on. So multiplication. Okay. In multiplication, in the abacus world, what we do is we do distributive property. Distributive property means what? It's a math rule. What we do is we break up the number into smaller parts. So instead of doing 2,000 times 2,000, we just need to do 2 times 2. That's all we need to do. Why? Because that's what we call distributive property. So that's why I did 2 times 2 is equal to 4. 0, 4, because it's a single digit. That means I got to make my single digits double digits. Every single digit has to be a double digit. So when I look, I go 0, 1, 0, 2, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. Why are we doing this? Because you need to make it a double digit. Just like how we talk about month, 05 is May of 03, right? May 3rd or even May 4th, right? Am I a teacher? I am now. So what we want to do, Fanta, do you see that? So what we're going to do is we're going to do 2 times 2. We don't need to worry about the digit. We don't need to worry about the zeros. The reason why is because we counted our digits ahead of time. I know I'm going to be somewhere around the 10 million. How do I know that? Because I counted my digits. 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense, Fanta? So when we do that, we can count it out. 1, 2, 3, 4, 5, 6, 7, 8. Then what do? Then we've already figured out where our answer is going to be. Because I'm over here, I know this is my ones place. Because I'm over here, I don't need to worry about these zeros because the abacus does it for me. That's why when I do 2 times 2 is equal to 4, I go back one column and I add my 4. Then I get 4 million. Did that make sense, Fanta? So when we're looking at multiplication, we do distributive property, but we use the abacus to help us track our numbers. So I now know that this is 4 million. We have our ones, thousands, and millions. And that's it. Right, Dalen? Oh, God. Good. Good. I'm so happy you got it. Hello, Chaotic. Welcome back. Thank you so much for checking in. Thank you. Jesus is my God 24. Hello. Fanta, did that make sense? So that was a little bit about multiplication on the abacus. Yep. That was a good one. So it doesn't matter how big your numbers are, as long as you have an abacus big enough to hold it. But yeah, you could do anything. You could do adding, subtracting, multiplying, and dividing. Oh, okay. So what are we doing? Wow, we're at 17,000. Thank you, guys. Thank you so much for liking the live. Okay. I don't know. IG. I guess. Can we do division? I'm still trying to understand division. Yes, let's do some division. Are we ready for division? Hello, Sammy. Hello, Sammy. How's it going, Sammy? It's been a little bit. Okay. Division. Ba-da-bum, ba-ba-dum. Good. Okay. Okay. Okay, wait. Hold on, Eve. Let me continue on with Fanta. You don't know. Okay. Let's try this. Okay, let's try this. Distributive property. Maybe this will be easier. Fanta, you there? Am I a school teacher? No. I am an abacus teacher. Okay, so we are going to count our digits. Do you see that? 58 times 2. 58 times 2, how many digits are there? There's 3 digits. 1, 2, 3. Right? So then we're going to count. We know we're going to be somewhere in the hundreds position. That's it. 1, 2, 3. So we're going to be somewhere in the hundreds position. We're not going to do 50 times 2. We're going to do 5 times 2. That's all we're going to do. 5 times 2. Because multiplication table tells us 5 times 2. Multiplication table does not have 50 times 2. 50 is a 5 and a 0, right? This would be 50. But we don't need to worry about that. We just need to worry about 5 times 2. 5 times 2 is 10. Add the 10. Notice that it says 100, which is the same as 50 times 2. But instead, the abacus tracks our digits. So we have 10. 1, 0. Then what do? We do 8 times 2. 8 times 2 is 16. Add the 1, add the 6. That's what we call distributive property. We broke up our digits. We do 5, and then we do 8. That is what we call distributive property. And so my final answer, do you know what my final answer is? Did that make sense? Is that better? Is your favorite class? No, it was not math. I think my favorite class was organic chemistry because the professor was so good at explaining it. It was crazy. Yeah, 116, right? 116. Good. 116. Did that make sense? How I got it? So we could do it again. Let's do it again. So again, we're going to have our place value. 1, 2, 3. 1, 2, 3. That made sense. That's better, right? Because the numbers are smaller. See, that's what I'm saying. If the numbers are too big, then it gets really confusing really quick. But the numbers are smaller. It's easier to digest. And we could do it again. So 2 times 4 is 8. 8 again is a single digit. I got to do 0, 8. 0, 8. So I'm going to do 8. 5, 6, 7, 8. Right? And then 6 times 2. 6 times 2 is 12. So I add my 1 and I add 2. So my final answer is 92. Did that make sense? We can do another one. Right? We can do another one. So we have 55. 55 times 9. 3 digits. 1, 2, 3. Right? Add in the middle. Yeah. So when you look, 45 plus the 4 plus the 5. I keep my finger here because then I can do my next one. 9 times 5. 9 times 5 is 45. Add the 4, add the 5. So my final answer is 495. You're stacking it. So in mainstream, right? In mainstream, we did what? 5 times 5 is equal to what? We did 5, 45, and then we need to bring down the 5, and then look, 45. So that's what we did. But we did it on the abacus. We did this first. So when we do 5 times, we did this first. We did this first in abacus world. So we do 45. See that? 450. And then we're doing this one now. Then we do this one, which is this. Then we add the 4, we add the 5. We add the 4, we add the 5. Okay, Daylin. Go get some sleep. I'll see you in my next live. Sleep well. Did that make sense, Fanta? Thank you. Mac Mooney. Okay, good. Okay, good. And that's what that's what multiplication is on the abacus. I don't know what that means. Thank you, Mac Mooney. I don't know what that means. Oh wait, I'll ask my kid. My kid? I had to ask my kids what NGL was, and then I had to ask my kid what is mango something. And I'm like, I don't know what that is. And then, oh, it is? Thank you, Jeremiah. Oh, I see. Oh, thank you guys. Oh, yeah. Oh, that's too bad. Thank you guys. Thank you so much. All of these acronyms, it's crazy. Okay, so thank you so much for the follow, Mac Mooney. Okay, so did the multiplication make sense? Are we okay? Is that okay? You want to do some more multiplication? If not, we can go into some division because I think Eve is still here for division. Okay, so how are we doing? We can do some more multiplication? Yeah? You want to do that? So we do. Okay, we're going to do it again. So we do 1, 2, 3. One more? Okay, not a problem. We do 1, 2, 3, right? 1, 2, 3. 1, 2, 3. 9 times 3 is 27. Hi, Jinx, welcome back. 27, right? We have the 2. We have the 7. Oh, maybe it would be nice if I did it like side by side. So we did 3, 1, right? What did we do? We did this one first. We did 27. See? 270. That's what we did. We did 270 because we did the 9 times. So then what we're going to do is we're going to do 9 times 1. 9 times 1. 9 times 1 is 9. 9's a single digit. So I go back one column, I add 9. Like that. Right? So what happens? What did I do? I did this. Add the 9. That's what I did. See? But because we start from here, if you notice, there's a 0 here. Crazy, right? But that's why we do the 0 to make it a double digit. So my final answer is 279. Thank you. Did that make sense, Fanta? Okay, so that's 2279, right? And then we can do it again. We have 42 times 5. 1, 2, 3. 1, 2, 3. 5 times 4 is 20. Add the 2, add the 0. There's a 0 here, right? And then 2 times 5. 2 times 5 is 10. Add the 1, add the 0. So my final answer is 210. Right? And we could do it again. This will be easy. Because we have 1, 2, 3. 1, 2, 3. 1 times do 300 divided by 5. 300 divided by 5. All right, we're ready for that? We're ready for division already? All right. Okay, Eve, are you still here? Eve, I hope you're still here. Okay, Fanta, you okay? Good morning, E. Good morning. Good morning.
Good morning, apartment. Good morning, doorway. Good morning, wall. Morning, ceiling. Good morning, floor. Ready to start the day.
That's for Lady E. All right. So, Eve, are you still here? That's the dividend in my divisor. I have another one. I just did this one.
Step 2, greet the day, smile, and say, Good morning, city.
That's for E. All right. That's enough playing. Okay, we're going to do division. Thank you, Lady E. Okay. What are we doing? We're going to do division. Division is what? We have to also find where we're going to put our answer, our quotient. We're going to use the abacus to do it. So we're going to do 3. Oh, maybe I should rewrite it nicer. I'm going to rewrite it nicer. We have 5 divided by 300. That's what we're going to do. All right. We have 3 digits, 1, 2, 3. Because we have 3 digits in my dividend, I need to subtract how many digits on my divisor. I have 1 digit on my divisor, so my final answer is 2. My position is at 2. 1, 2. So here, 1, 2. What do I do now? I'm going to put my dividend on the abacus. 1, 2, 3. It's just there as a placeholder. The reason why it's there as a placeholder is so then I can do subtraction on the abacus. So my next question is 5 times what is equal to 3? That doesn't work. You can't do that. So you need to bring down the 0. You will know 5 times 6 is equal to 30. Add the 6, take away 30. Take away 3, take away 0. So my final answer, if you notice, is 60. 6, 0. And that's how we do division. Jeremiah, did that make sense? How are you doing, Fanta? Would that make sense to you? Is that okay? You all right? We can do more. Eve, are you still here? Okay, good. How are we doing? Am I a teacher? Do you know? I know Heather. Are you a teacher? I am a teacher. I am now. Thank you, Heather. Where's Eve? Eve, are you still here? Oh, did Eve leave? I'm shocked. I'm ready for the next. Oh, you want to do it? Okay, let's do another one. I'm shocked. All right, let's do another one. I have to use this one. I gotta change another. I gotta get another. Okay, we'll do this one. 2 divided by 9, 8. Okay, now we do it again. We have to do it again. We have to count our digits. We have our dividend, 1, 2. There's 2 dividends. Take away how many digits on the divisor? 1. So we take away 1. So 2 minus 1 is equal to 1. What are we going to do? We're going to put our digit here, right? 1. This is the ones place. Hold on, Siren. And then we do 90. We do 8. Again, this is our placeholder, right? This is our placeholder. Hello, Angie. And then what are we going to do? We're going to do 2 times what is equal to 9 or less. what's going to happen? Because we can do this, we can kind of do this, right? We can kind of do, we got to skip this column and we're going to add it to here, right? Skip this column, we got to do it here. Thank you, Lady E. Yes, so 2 times 4 is equal to 8. Add the 4, take away 8. Take away 8. I'm going to take away 8, right? So my final, my answer is 1. So I have to do it again. 2 times what is equal to 1? That doesn't work, right? We got to bring down our number. What number are we going to bring down? What number are we going to bring down? 8. Thank you, Angie. We're going to bring down this 8. Do you see that? So it's got to be 2 times what is equal to 18 or less. So that means we're here. 2 times 9. Thank you, Angie. 2 times 9 is equal to 18. Add the 9, take away 1, take away 8. So my final answer is 49. Fanta, did that make sense? Thank you, Siren, for the answer. So what did we just do? We did division, but the way we do division on the abacus is find the missing multiplication factor. Lady E, do you remember how to do the division? Oh, that's right, 49. So my answer is 49. Whew. I picked up the last bit. Yeah, right? It makes sense. We can do another one. Right? Let's do another one. I know these questions are easy, but if the questions become too difficult, then I never understood that. Hi, Brian. You never understood what? The abacus? Do you know how to read the abacus? Do you know how to read the abacus, Brian? I think I want to do... Oh, hello, Siren. You showed me once, but I forgot. Oh, let's do a review. Thank you so much for joining. Let's do a review. Thank you so much for liking the live, everybody. Let's do a review. We have 1, 2, 3, 4. The top bead is of... I'm sorry. The beads touching this horizontal bar is counted. So this is 4. We have 5. The top bead is a value of 5. We have 6, 7, 5, 6, 7. Notice it's 5 plus 2 is 7. 8, 5 plus 3 is 8. And then 9. 5 plus 4 is 9. And then we have 10. Every column is a place value. So we have our ones, tens, hundreds, thousands, and 10,000s. Every column. So when we look, we have 1, 10, 100, 1, 0, 0. 1,000, 1, 0, 0, 0. And then we have 10,000, 1, 0, 0, 0, 0. Because every column is a place value, I have a label. This label tells me that this is my ones place. Because I have my ones place here, I know that this will be my thousands because now I'm grouping them. This will be like a comma. This is the ones, this is the comma for the thousands. And then after the ones, we have our tenths, and then we have our hundredths. This is the decimals. The decimal sits between the ones and the tenths. It doesn't sit on a place value. It sits between. So that's what the decimal is. So when we're looking, we have 125, 1.25. And then we can do 10, 11, 11.25. Does that make sense, Siren? So when we have it, we have 5555555. And then we have 6, 6, 6, 6, 6, 6, 6. And then 7, 7, 7, 7, 7, 7, 7. 8, 8, 8, 8, 8, 8, 8. That's what 8 looks like, right? Because every time the beads are touching the horizontal bar, that's what's being counted. These ones here, right, are not counted, so don't count it. We have this one is 9. 5, 6, 7, 8, 9. Did that make sense, Brian? How are you doing, Siren? Did that make sense? And then we have what? We have 10. Why? Because this is my ones, this is my tens. That would be it. Oh, good. Thank you, Siren, for letting me know. Yeah. I didn't know you didn't know. I didn't know you didn't know. Haha. Thank you, Alex. 67 is the 60, right? 5, 6, 7. 5, 6, 7. That's what 6, 7 is. And then we have 167, 68, 69, 170, 170, 171, 72, 172. And then we have 200, right? Why is this 2 and not 7? Because the top beat is not touching. This is 7. 5, 6, 7. 2 plus 5 is 7. 2, 2. 272. And then we have 372. 3, 1, 2, 3. This is 5. This is not 3. Because the top beat will always be 5. No matter what, the top beat is always 5. So if I have 3, 1, 2, 3, I add the 5. Now we have 8. 8. 5, 6, 7, 8. But I don't have it. I do this. This is 3. This is 7. Even though there's 3 beads. So then this is 2. 1, 2. Right? 2 beads is different than 3 beads. But the 2 beads, if you notice, does not have this 5. This is why it's 2. When we add the 5, then we have 7. But we don't have the 5. This is 2. Yes. Thank you. So yes. Hey, Riri. Riri. The 5 will always be the blue bead. The top bead. The top bead is always 5. So if I did this, this is 5, 5, 5, 5, 5, 5, 5. Yep. This is 0. None of the beads are touching the reckoning bar, so that's 0. When the beads are touching the reckoning bar like that, that's 2. This is 3, 4, and then 5. 6, 7, 8, 9, and then 10. How do we know which one's which on the hundreds? Here you go. Right here. So when you look, this is my ones place right here. Because this is my ones, this is a label. Do you see the dot? That's my ones place. So this is my ones, tens, hundreds, thousands, 10,000s. Notice there's another dot here. That is my grouping. Good. Okay, good. I'm happy that made sense. So when we're looking, right, we have our ones and our thousands. So we can do this. That would be 1,000. 1000. Did that make sense, Riri? Hey, Riri. I got it now. Oh, good, anime. Anime Inca. Good. Okay, good. So then we can count. Okay, let's see. Okay. So let's see how well you guys do. So here's my number. Here is my number. Thank you so much for liking the live. Here's my number. What number do you think this is? So if this is my thousands, my hundreds, my tens, and my ones, what number do you think that is? What number do you think that is? That is not 0. How do you get 0? There's 4 digits. Thank you. Thank you. Yes. So it is 8,703. Well done. 3, 1, 2, 3, right? 8, 5, 6, 7, 8, 1,700, 5, 6, 7, 0, and 3. 1, 2, 3. Well done. Well done. So that will take me to, that's what that is, right? And then it takes me to here. So what number do we think this is? We have our hundreds, thousands is over here, right? Thousands, hundreds, tens, and ones. What number do we think this is? Thank you. Yes, Riri, it is 599. Thank you, MB. Well done. Right? It's 3 digits, right? Because this one is a 0, so that's not counted. 599. Well done, well done, well done. So then we have our next number. What number do we think that is? Simple to use, easy to understand, right? Simple to use, easy to understand. So we have our thousands, hundreds, tens, and ones. I don't know if Siren is still here. I don't know. I just joined. Oh, good, Britt. Hey, Angie, good. Thank you, Fanta. Thank you, Anime. Yes, well done, everybody. Well done. Thank you, Anime. Thank you, NB. Yes. 8,000, right? 291. Well done, well done. So what we're doing is we're learning how to read the abacus. And our next number is this. We have our thousands, hundreds, tens, and ones. What number do we think this is? I'm concentrating on coloring. Thank you, Anime. See, well done. We have 8,536. Well done. 8,536. 8,536. I need to move it up. There we go. There we go. There we go. Angie. Okay. So we have thousands, hundreds, tens, and ones. Thousands, hundreds, tens, and ones. What number? Little Jack O'Bean. Thank you, Riri, for the follow. 200, 2,000, 1, 2, 900, 5, 6, 7, 8, 9, 1. Well done. 1. And then 9. 5, 6, 7, 8, 9. So when we're looking little, it's 2. Do you see how this is 2? So when we're going to count ones, look the same. Ones and hundreds. Ones and hundreds are the same. Thousands is a 2. Tens is the 1. So when we're looking, we have 9. 1, 2, 3, 4, 5, 6, 7, Why? Because 5 plus 2 is 7. 5 plus 3, 1, 2, 3, 1, 2, 3, and 5 is 8. 9. 5 plus 4, 1, 2, 3, 4. 5 plus 4 is 9. And then what's after 9? 10. 1, 0. 1, 0. Yes, Sarah, the top bead is a value of 5. Yes, well done. So when we do 5, that's what 5 is. This is 50, 5, 0. This is 500, 5, 0, 0. So then this number is 9. See that? 9, 5, 6, 7, 8, 9. This is 1. I didn't know I'd learn this time of night. I know, right, Phil? It's like in the middle of the night and we're learning how to do math. Thank you, Siren, for the follow. Thank you, Siren. So when we have 1, we do 1. That's what 1 looks like. Right? 1. So this is 19. 1, 9. And then look, this is my hundreds. Every column is a place value. Thank you, Britt. So every column is a place value. Right? So we have our ones, tens, hundreds, thousands, 10,000s. This is a 4-digit number. Ones, tens, hundreds, thousands. That's why this is 9. So we have 9, 1, 9, 5, 6, 7, 8, 9. And then we have 2, 1, 2. 1, 2. The last 2 cents. Yes, exactly. The last 2 is the cents. Tenths and then hundredths. So our decimal sits between the ones. Good, Sarah. The finest ninja has a poke. If you're not understanding what I am saying, then I cannot help you. If you don't just sit and just pay attention, then you will be fine. But if you're not going to sit and pay attention, yes, thank you, little Jacobine. Yes, you're right. So it's 2,919. That's what it is. You're well done. Well done. Right? So we're reading the numbers on the abacus. Anytime the beads are touching the reckoning bar, it's counted. This is a 4-digit number. 1, 2, 3, 4. This is 4 digits, right? When we're looking at each column represents a number. This is 9. This is 1. This is 9. This is 2. Well done. Well done. Well done. So let's try a new one. What number do you think this is? Okay. Hey, you're still here. Which set do you I have a question. Is it for you or is it for a child? Never used an abacus before. 72. Yes, you're right. 72. Totumo. Both. If it's for a child that is 3, 4, 5, 6, 7, I would do this. But if it's for you, I would suggest to get the 13 column one because it will extend to multiplication and division. That's what I would do. But it is up to you. Obviously, it's up to you. But for the kids, I mean, I have adults that like this one. It's sufficient for the beginning, but then you're going to want to graduate because when the numbers get bigger, you will not be able to utilize the abacus as much. That's why, right? So if you want to just do the 1, you can do 13 columns out the bat because you can do the small numbers on the 13 column one. But when you get to multiplication and division, it is best to use a 13 column one because you have enough space to do things. Good. Thank you so much. Abacus is cool. Thank you so much, guys. Yes, 72. Does that make sense? Totuma? Yes, 72. Let me write that out. 72. Well done, everybody. Thank you. Yes. What about books? The books, okay. So the books, if it's for anybody less than 5, I would do the preschool one because I was trying to get them to understand what the numbers are. But if it's for you, I would suggest either the there's a 3-digit, there's a 2-digit mazes. There's also a 4-digit maze, but that's coming in later. If you can't wait, I do have my full I do have my full one here. If you're okay with buying this one, I do have an abacus for adults. I do have one for abacus for adults, and it looks like this. It looks like this. This is the one I made specifically for adults. So for you, I would get this one. And it goes all the way to adding the 5, taking away the adding the 5, take away the 5, add the 10, take away the 10. And then there's a thing called a 2-step equation. The 2-step equation will be much better for you because you really need to solidify understanding how to add the 5, how to minus the 5, how to make a 10, how to take away the 10. So I would recommend this one for adults. But if the kids are younger, like say 2nd grade, you can start them with the 2-digit. If the kids are 3rd grade, I would probably start them off with the 3 digits. So when we're looking, the reason why is just the numbers are bigger and they understand how to read it. That's what they would do. So, and then it's the maze again, right? And then there's answers in the back. What about a teenager? Well, what kind of teenager? Like a 13-year-old or an 18-year-old? I think for teenagers, I think I would still start with the mazes, but there's a 4-digit maze that I'm still trying to I'm still bringing into the TikTok shop. But right now I only have a 3-digit maze. I do have a 4-digit maze if you want to go to this place, and that's my name. There's a 4-digit maze. I think a 16-year-old would enjoy. And that's what we're doing, is we're doing the 4-digit mazes, right? What about a 6th grader? I think the 6th grader would either enjoy the 4-digit maze or the 3-digit maze. Yeah, I think the 6th grader might enjoy the 3-digit maze or the 4-digit maze. It all depends. So, but thank you for asking about the books. I appreciate that. And for those of you that are interested, I do have books in my TikTok shop, or I have it here. My name is Lynette. Thank you, everybody, for joining. Thank you, everybody, for joining. And my books are very specific to the abacus. They do adding, subtracting, and they're going to go into multiplication, and I'm going to do division, but I'm not there yet. Oh, thank you, Angie. Oh, thank you. That was cool. Thank you so much. Yeah. So we did that. We're doing the 3-digit maze. So items 3. Yes, items 3 will come with an abacus. Items 3 comes with an abacus. Items 15 is the 13-column abacus. Yes. If you're looking for another package, I do have the item 1, which is the 3-digit maze, and it comes with this abacus. And then the item 2 comes with the 2-digit maze with the abacus. Yeah. But yeah, the other one would be for the abacus for adults, I would go here. Where did the abacus come from? The abacus come from Mesopotamia, and it was before Christ. It was before Christ. I think it was like 500 BC. That's when abacus came around. And why is it important? Because we can see the numbers instead of trying to figure out what the symbols are in your head. So if you notice, these numbers are actually symbols. This is not an actual thing, right? This is like a letter, like the letter A or letter B. These are symbols. So what we do in the abacus is we solidify it. So when we look, we have 1, 2, 3, 4. We can see that this is 4. Because we know that this is 4, we don't have to say, oh, this is the number 4. right? This is 4. We could see it. This is 5. Now we're representing. We're representing the numbers. Here is 5, and then we have 6. We have 7. We have 8. And then there's 9. This is 9, right? And then we have 10. That is why it's important. Because it's easy to see. That's why it's important. If you can see the numbers, you will be able to add, subtract so much easier instead of doing it on the paper. Because you know what I've noticed, that even if we have abacus, right? We have abacus on the paper. We have it on the paper, but you know what? Having it in real life in 3-dimensional, our brains can see it better. So I could see this better. I mean, you guys are seeing it through a video, but 3-dimensional, I can touch it and I can move it. So that I know that this is 70, I know this is 2. How do we add and subtract? We could get to that. How do you use the abacus that has 2 beads on top? Here, hold on, Angelique. So that is what we call a Chinese abacus. And the Chinese abacus, thank you so much for the question. It works very similar to the Japanese abacus. So when we look, we have 1, 2, 3, 4, 5. And then what are we going to do? We got to trade it in. Hi, VC, welcome back. That one is cool. We could trade it in to make it a 5. So then we do 6, 7, 8, 9, and then 10. Trade this in to make this 10. But then we have to trade this in to make this 10. And then 11, 12, 13, 14, 15. And then we traded it in. 15. And then 16, 17, 18, 19, 20. Trade it in. That's 20. That's 10. So now we're at 20. Does that make sense, Angelique? Okay. How are we doing? So then, just like on the abacus, hello, Sarah, thank you. So we do it again. 1, 2, 3, 4, 5, right? That's 5. 5, 5. 6, 6, 7, 8, 9. 7, 8, 9. But then this one has an extra bead at the bottom. So that's 10. But on the abacus, on the Japanese abacus, it's redundant. We don't need to trade it in. We don't need to trade it in. We just do that. So we know that this is 10. Extra steps for Chinese, simpler with Japanese. Yes, but you know, the methodology is different in Chinese. The methodology in Chinese is to count up, as opposed to the Japanese abacus uses formulas. They use the concept of how to make a 5 and how to make a 10, which is crazy. I didn't know. I never learned how to use the Chinese abacus until somebody came onto my live and told me how they did it. Because they learned how to do the Chinese abacus, and I realized what they do is they count up. But on the abacus, on the Japanese abacus, we use concepts. We use a balancing. Can you do larger numbers on a Chinese one? It's the only thing that's different is the amount of columns. So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you can do 11 digits on the Chinese abacus. But if I have a 13 column abacus, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I can do more on this one because I have more columns. Because I have more columns, my numbers can be bigger. For the Chinese abacus, 1, 10, 1s, 10s are different for the single columns. Yes. So when we're looking at this, the way they do it, they start from the very edge. So this is the 10, but then this is 10. Yeah, you could do that. You could do 10. And then this would be 100. But this is also 100 if you think about it. Because this is 10, we traded into that. That's why I find it confusing, because this is 10, but we're on the ones place. You know what I mean? So that's why you would do that. That's why you have to trade it into this. This is 20, 2 and a 0, but that doesn't look like 2 and a 0. This looks like 2 and a 0. And then we have 30, right? Or we have 30, 5, 6, 7, 8, 9. 30. There's no bundle with the adult abacus. Not yet, because it's not in my TikTok shop yet. When I have it in my TikTok shop, I was going to do it with the bundle. My brain hurts. For calculating, we trade. Yeah, for calculating, we trade on the abacus. Oh, good. I'm happy your brain is braining. So when we're looking, right, we want to make sure we understand that this is 1, right? Because it's touching the horizontal bar. I need a potable or portable. I wouldn't get the Chinese one because it's not modern. Everybody now uses the modern abacus. The Japanese abacus is the more modern one. Portable. Not like potable water. Yeah. So the Japanese abacus is more modern. And then everybody is using the Japanese abacus. There's not too many. I don't know any school that does the Chinese abacus anymore. I think the Chinese abacus will become upgraded to the Japanese abacus. Yes, you can multiply on this. Yes. So for the Chinese abacus, 1s, 10s are different for single columns. Yeah. Thank you for the follow, little Jacobine. So we're okay with how to read the abacus now? We're okay with that? I wish my abacus... Oh, sorry. I wish my school taught abacus. Yeah, you know what? I'm trying to get there. I want to be able to get to a point where I'm teaching the world... I'm teaching the Matrix how to use the abacus. Hey, Xavier. Hello. Do the things on the top where... Yes! You're right, finest ninja. Yes, the top bead is always 5. You're doing good. Yes, the top bead is always 5. Yes, so this is 5, 5, 5, 5, 5, 5, 5. That's what this is. So if I was to write it out, right, we would have 5, 5, comma, right, because there's there. 5, 5, 5, point, right here. And then 5, 5. 5, 5. It's ninja. Naya. Sorry. I apologize. Okay. I'm sorry. Naya. I'm confused at the point. This is my 1's place. It's a label. My 1's is a label. That's all it is. It just tells me where the 1's place is. So when you look, it just labels that this is my thousands, like a comma. So when we have, this is my 5, this is my comma. So we have 55, comma, right? I know that this is my thousands. And then we have 555, right? Decimal sits, but we just have to know the decimal sits between the 1s and the 10ths. That's it. The 1s and the 10ths. The decimal sits between here. This is a label for 1s. That's it. And then 55. Naya, did that make sense? I'm so happy you got it. So when we're looking, what are we doing? Kinda. It takes time. You know why? It's because it's unfamiliar. It's just unfamiliar. That's all. Thank you for the follow. Thank you for the heart meet. Hello, Jeremiah. I'm going to start a petition to make Abacus available for everyone in all schools. Yes, thank you.
Welcome to the real world.
Yes, I am here to teach Abacus to the Matrix. Okay, good. Yes, Naya. Good. It takes time because it's just unfamiliar. This is the way.
This is the way.
Yes, Jeremiah. It is the way. Because you can see the numbers. When you see the numbers, it'll be easy to understand. That's all it is. Okay. What are we doing? We're doing multiplication? Did we want to do multiplication? Yes, Angelique. Okay, let's do some multiplication. Are we ready for some? I have my paper. Jeremiah, are you ready for multiplication? I... Did I leave it somewhere? Ha ha, I'm so ready. Oh, good. Okay, we did this, we did this, we did this. Where are we? We gotta do some multiplication. Okay. Hold, please. I've got a lot of books. We're gonna be doing some multiplication. Hold, please. There we go. Okay, so multiplication. What time is it for me? It is 11:47. I am in Pacific Standard Time right now. No! Oh, Siren, you're gonna like it. You're gonna like it. It'll be fun. It'll be fun. No, not yet. Not yet. The adult book is not in my shop yet. I just ordered it, but it won't be in the shop till about maybe 3 weeks from now. Yeah, it's 2:40, and you're learning math. Official anime. That's crazy. I'm excited. Oh, congratulations. Oh, 148. Yeah. See, you guys are crazy. You guys are crazy. The adult version of the Abacus. I have an adult version. I have an adult book. I have a book for adults. And it's over here. My name is. But it will be in my TikTok shop soon, just not right now. So that's my name if you're looking for the adult book. I need an abacus. Oh yeah, I sell the abacus on my TikTok shop. I sell the abacus, depending on what abacus you want. I have the colorful one, and then I have the 13 column one, and that was what Totuma was asking. So this is my 13 column abacus. I do sell the seven column abacus as well. It's on Amazon. Yes. So the adult one is available here, and that's my name. Yeah, it just got published. I guess this is what adults do on their free time instead of sleeping. Siren. Thank you, Jeremiah. Thank you so much. I appreciate that. It was a long time to finally get it out the door. So now, since I'm done with my introduction to Abacus for adults, I'm going to go into doing some multiplication, and I'm very excited for multiplication books. The reason why is because I was going to break it up. Into really manageable chunks, and I'm very excited for the new multiplication books. I'm super excited, actually. I just got to get it done and get it formatted and put it out the door. Yep, and publish more books. This is my 14th book, so I'm working on number 15, and I didn't think I was going to have that many books, but this is crazy. Who taught me? I did not grow up with Abacus. I actually learned the abacus when I was 30, and I've been teaching abacus for about 20 years now. So that's, if you add it all together, you'll know how old I am. Who taught you the abacus? We bought it from a franchise, and they were located in Canada. And he was dealing us, but then what they were telling us is they had to memorize, and I'm not one to I don't like memorizing. I want to know why. So when I teach you guys how to do the abacus, I tell you why we're doing it. So when we talk about finding the numbers, why are we counting our numbers, so we know what we're doing. So here's the question. The question is 33 times 1. This is easy. I know it's easy, but I'm showing you the concept of how to do multiplying, right? So the multiplying is distributive property. Distributive property is a math rule that breaks up the number into smaller parts. So that means I'm going to be breaking up 3 and 3. I'm going to break it up. So we do 1 times 3 is equal to 1 times 3 is equal to 3. Because 3 is a single digit, I need to make it a 0, 3. I need to make it a double digit. Before I do that, I need to count how many digits I have in my question. 1, 2, 3. So I'm going to be somewhere in the hundreds realm. But because I have 3, I'm going to do 0, 3. I add 3 here. 1, 2, 3. And then I do it again. 3 times 1 is 3. 3 is a single digit. I have to add another 3. 0, 3. 1, 2, 3. So my final answer is 3. So my answer is 3. And then I have a next question, right? My next question. I have, again, distributive property. Other than the preschool books to get a child started, I have a lot of printables, and I'm actually working on another child book. I'm actually working on another book 1 for children, but that's not published yet. I do have printables, and I do have printables. They're located over at the TPT. Do you know Teachers Pay Teachers? And this is my name over at TPT, or my website. I do have printables on my website as well, and I do have printables over here. You can, yeah. If you want to DM me, we can talk more about it. It's up to you. I'm not supposed to say anything else about it because TikTok would suppress my live. But it is available. Think you will do. Oh, okay, yeah. Not a problem. I have to be careful, right? So I do have like a lot of cut and paste, and I have some. Oh, if you're okay with, I have it themed. Oh, okay, thank you, anime. Thank you. I'll see you in. We will get into school. Thank you. I will try my best to get into the schools, but that's the hope, right? For right now, to Totuma, I do have it themed. I mean, Christmas is coming around, and Halloween's coming around. This one is only counting from 0 to 10, and when we do 0 to 10, thank you, coolers. This one is 0 to 10, and then this is about understanding how to do the maze. They have to find the number, and then they have to color it in. So this is 1. This is the maze for 1. So they have to know what the 1 is. This is the abacus. This is the number. And then because there's an empty space, they have to put in like Play-Doh balls. Play-Doh here. How many Play-Doh goes here? Only 1 Play-Doh goes here. And then they have to do 1. So then they have to, and then they find the number 1. And it's a maze to get to the finish line. Right? And so this is my abacus for children with, and this is a cutting. So this is a Halloween one. And so I wanted them to practice their motor skills. And this is only to recognize what the numbers are. Right? And then we find the abacus. What else? that's the maze, and then we have the dough counting. So you color, you trace the number 1, you color in the abacus, and then you color in the 1. This is the dough ball. You put the dough. So I try to put it as a 10 frame. That's what that is. And then it just goes through every number. And again, I do scissors cutting. And then I teach how to do how to make a 5 to 9. So again, so this is just a brief overview of what the abacus is. And then we talk about place values. So we talk about 10, and then we have 2, and then we talk about pairs. So the pair is 1 and 1, and then they have to cut, and they have to match it here. And then this is counting forward and tracing. This is about tracing. This one was kind of cool. This one is, here's the haunted house, and then these are the ghosts. So you have to cut out all the ghosts. And then from here, this one is in my TikTok shop. That one. That's number 5. And so they have to match this ghost with the house. And then this one, okay, this one is called the clothespin activity. Cut out the numbers, trace the numbers, and then you have to cut this out. These are cards, and so there's nothing in the back, right? So these are cards, these are one-sided cards, and they have to know what 2 is, so they have to clip a paper clip, not a paper clip, you could do a paper clip or you could do a clothespin, and the reason why it's a clothespin is because then you can practice the how to pinch. And then you can play with them. So if they know what the 2 is, what is before the 2? Well, 1 is before the 2. Well, what's after 2? After 2 is 3. So I made it where it goes to 1, 2, and 3. So you can talk about before, after, and middle. Yeah. And that's what the clothespin activity is. And then we go count backwards. We're counting backwards. And then we talk about comparisons. I love that you're doing it. I really hope it gets into schools. Oh, thank you. I hope so too. I'm trying to really make it, I'm really trying to make abacus more mainstream. That's what I'm trying to do. Because in abacus world, it's nothing like this. In abacus world, the questions, the books come like this, which is really quite boring. And I feel sorry for my kids because this is what they learned. And then now, since my kids are older, I have more time to be creative. And so I'm trying to be away from this, but make it more interactive. And that's why I wanted to talk to kids, younger kids. So then here's the Christmas one. The Christmas one. Did I do Christmas? Oh yeah, here's the Christmas one. So the Christmas one goes from 0 to 20, and it's obviously it's themed. But this one we can actually do adding and subtracting. So depending on how big it is, right? Depending on how big, we could do. Yeah, so again, these are the activities, right? And then we have our numbers, and I talk about how to do the 5 and so forth, right? And then we do matching, and then afterwards we can start going into adding and subtracting. Yeah, so this one is, they're a little bit older, they can start learning how to add and subtract. Thank you, Miron. Yeah. So this is the Christmas one, and I do add the mazes as well, and then a lot about the adding and subtracting. Yeah. So, but this one is themed. I did the adding plus the 2 minus the 2 plus the 7. Hold on. Okay. Honest question, why would you want to have this if you have a calculator? You can use a calculator. That's fine. Here's a question. No, not worries. Hold on, Jeremiah. Let me answer the questions for Love My Doggo. Here's a question for Love My Doggo. Do you do like Sudoku or crossword puzzles? Do you do jigsaw puzzles? How about word searches? Do you do any of that? Do you play games? Right? Any kind of game? Because it's all about strategy. Chess? Do you play chess? Or even logical puzzles? Any type of puzzles. Well, why do you do it? You can do other things. Thank you, Jack. That's why you like the abacus. Because it's like a little puzzle, right? I don't know if Love My Doggo is still around. Okay. Anyways. Okay, so Jeremiah had a question. Here is the question. Thank you for the question. So we have 8 minus 2 plus 7. So on the abacus, we have 8, right? Minus 2, we can do it, right? Take away the 2. When we plus the 7, this is where we get to two-step equation. Okay, I apparently Love My Doggo left. Ah, thank you, Totuma. Thank you so much. What? Wow. Okay, 7 plus the 7. We want to add the 7. To add the 7, what do we do? What is add the 7? Plus the 7 is equal to what? Plus the 10 minus 3. We know how to minus the 3. We want to plus the 7, take away the 3. We have no beads to take away the 3. What do we do? Do you remember, Jeremiah? No, thank you. That will help my son so much. When he's old enough. How old is your son? Oh, thank you. Thank you. I keep messing up your name and I apologize. Totuma. 14 months. He's so small. Yes. Minus the 5 plus the 2. You're right. Minus the 5 plus the 2. So what did we do? We did a two-step equation. This is a two-step equation. We did this, goes to that. That's why you're stuck. You have to remember. It's Lewis. Oh. Thank you, Lewis. I appreciate that. Thank you so much. Yeah, my kids, I feel sorry for my kids because they didn't get a chance to do worksheets like my worksheets. They had to go through the grind and it was very difficult for them. So I'm hoping that the activities that I do create will provide more fun for the kids. So, Jeremiah, did that make sense? So what we did is we did a two-step equation. So this final answer is what? It's 13. Can you continue with in the next column? Can you continue with the plus 7 with the next column? Yeah, we can do it, right? So what is plus 7? Is that what you're talking about? If we want to plus the 7, what do we do? Plus the 7 is equal to plus the 10 minus 3. So we have to plus the 10 minus the 3. So my final answer is 20. Is that what you're talking about, Riri? How I got 14? I don't know how you got 14. Because did you forget to add the 2? I meant the steps for getting 13. Oh. Okay, let me redo that. So the question is here. The question is 8. So we have 8 minus 2, right? No. Hold on. You're okay. We're going to do it again. So we have 8. 8. Take away 2. We can take away 2, right? Not a problem. 1, 2. Take away the 2. So my question is 6. Now I have to plus the 7. So what are we doing? We're doing a running total. Thank you, Matthew. Hold on just a minute. Right? We're doing a running total. So we have to add the 7. Add the 7. We know what? Lynette! That's my name. Welcome back. Hello, Lynette. And you spell it the way I spell it. That's fantastic. 13. Oh, yeah, hold on. But see, what are we doing? We're doing 7. We want to add the 7. Plus the 7 is what? Plus the 7 is equal to plus the 10 minus the 3. How do I know this? Remember, 7 and 3 is equal to 10. 7 and 3 is equal to 10. Because 7 and 3 is equal to 10, we got to make our 7. So we have 6. Let's do our little bricks, right? If I did our brick, right? This is 6. 6 is right here. And then we want to add the 7. 7 is right here. But look, 5, 5. This is 6. 5, 6, right? Now, I need to make a 3. But we cannot take it from here. We can't take it from here. So what do? Thank you, Riri. Yes. But the problem is I need to minus the 3. Cannot minus the 3. I got to take it out from here. Minus the 3 is what? Minus the 5. Yes, Siren. I have to minus the 5 and then add the 2. So I have to add the 2. So I'm going to take this away. I need to add the 2. Then what do? Right? Then I can make my 10. 5, 6, 7, 8, 9, 10. That's right. I got it. That's why. 1, 2, 3, 4, 5. There we go. So we have 13. Sorry, I had a brain fart. It's late. Sorry, it's really late right now. It's so late, Lynn. Cholo, you're back. Yeah. So wait, what are we doing? Okay. So we have 6. There we go. 6, right? 7. 5, 5, 6, 7. And then we want to add the 6. But what do? To make a 3, what do? We have to break this apart. We have to take it away. We have to take it away. Because we take it away, because what are we doing? We're trying to minus the 3. The 3 is in here. We got to take away the 3. The 3 is here. Whoa. The 3 is here. That's what we're doing. And we put it here. That's what we had to do. We had to take it away from the 6. So then we have our 10. 5, 10. 5, 6, 7, 8, 9, 10. So that's why it's a 2-step equation. Because this 3 cannot take away. If you notice, I don't have a 3 to take away. So I add my 10 and I minus the 3. Minus the 3 is equal to minus the 5 plus the 2. That's what I did. Minus the 5. That's right, I did. So I had to break this apart. I had to take away the 3 to add the 2. So my final answer is 13. Because this number and this number is the same. Thank you for going in the equation. Oh, give your brain a rest. It's 3 a.m. So many views. Yeah, I know, right? It's crazy. It's almost 200 people. Okay, so it includes algebraic math. You know, we do. How do you do it with the abacus? How do you do it in the abacus? Okay, so here we have 6, right? Plus the 10 minus the 3. I want to take away the 3 here. Because I cannot take away the 3, I know I need to minus the 5 plus the 2. So I minus the 5 plus the 2. So my final answer is 13. That's why. Because of this. This is what I call a two-step equation. You need to know how to minus the 5. Remember how we add the 5? And minus the 5. Oops, minus the 5. We have a plus the 10, and then we have minus the 10. Those are the two sets of formulas you need to memorize. This is the reason why. The reason why is so then you can add and subtract everything and anything under the sun. There he is. There he is. So we have that. Yeah. It's way simple on the abacus. Yeah, it's simpler on the abacus, but I'm trying to I was trying to understand, I was trying to explain the bricks, the cubes. Is that the book I got? That's the adult book. The adult book has the two-step equations. The adult book will have the two-step equations. The other books don't have it yet. I haven't done that book yet. I have to do that book for the kids. I have a student that's going into doing two-step equations, and he is going to be 5. He's already 5. But yeah, the adult book does it. Oh, so yeah, Riri, just so you know, abacus is the gateway to complex math. And so when we're talking about it, that's what this is. What did we do? We did 4 plus 1 is equal to 5. What isolate the variable? We isolate the 4. When we isolate the 4, then we substitute this information with the 4. So just like how we did 4 plus 4, I want to add another 4. To add another 4, I need to plus the 5 minus the 1. Right? And then we did it again. So we can do it again. We have 3 plus 2, 3 plus 2 is equal to 5. So with this one, 3 is equal to 5 minus 2. Why are we doing that? Because if I have 4, I want to add the 3. I'm going to add the 5, take away the 2. So if you notice, this becomes a different variable. This can actually do x is equal to 5 minus 2. But we can take it one step further. We can make our 5 a constant variable, and then this this 2 becomes a y. So we can do 5 is equal to x is equal to 5 minus 2, because x equals plus the 5 minus y. See how it's the same? And it's the same thing over here. It's the same thing with the 2. Because the 5 is our constant. We have 2 is equal to plus the 5 minus the 3. Yeah. And so we start, and that's what it is. It's the beginning parts of algebra, but they are known variables. The variables are known. So that's why it's really interesting that abacus, the way the abacus method, it translates. Which book is this? It is this one over here. That one. It's number 14. This one is a dry erase, and this one is available in my TikTok shop. And this one, and I like this one because I show you what commutative property. I show you the addition, and I show you the subtraction. And then we do commutative property. It's kind of a different version. The reason why is because the definition is only about the addition state, but in abacus we needed to do it with the subtraction state. So when we look, then I give you also this one, which is making of the 10. And then making of the 10, how do you calculate 3 minus, do you use all the beads? 5 minus 3 is equal to 2. Okay, hold on for the multiplication. Hold on just a minute. So when this also provides a making of the 10, and then we have adding of the 8 is equal to plus the 10 minus the 2, or minus the 2 plus the 10. It's good to be flexible, but then here is where it gets great. Because I give you the formula, I give you this process, right? And I give you an example question. I label it, so this is the plus 5. After the plus 5, there is a minus 4. I'm sorry, minus 4 and a minus 5. They're back to back. So then we have a 3, and then we say minus the 3. Hello, Missa. Okay, little Jacobine, have a good night, and I'll see you in my next live. So we have adding the 2, and then take away the 2. And then adding the 1, and then take away the 1. And then there's the making of the 10. And it's the same thing. Adding of the 9, minus the 9. Adding of the 8, minus the 8. Have a good night, Jacobine. And then adding of the 7, minus the 7. So then it goes all the way to 1. But then it gets even better. Lewis, this is the framework. Here's the question. There's the workflow. You need to know if you need to add or subtract. If there's enough beads, the question is 7 plus 4. Here, 6. We'll do 6. 6 plus 7. Is there enough beads to add the 7? No. So what do? We have to use the plus 5. Cannot, because there's no plus 5. We have to use the plus 10. Plus 10 is plus the 10 minus the 3. Can I take away the 3? No. So then I have my framework. Minus the 3. Can I take away? No. So can I minus the 5? Yes. So if I minus the 5, I can minus the 5 is equal to plus the 2. So minus the 5 plus the 2. So my final answer is 13. So this is the workflow. I love the ability to interchange between. Yes, exactly. It is not 12. It is 13 because I did 7. I said 6 plus 7. Thank you for the follow. Sweet Japanese. Okay. Riri, did that make sense? How do you calculate the 5 minus 3 if you use all the beads? That's what it is. You need to know minus 3. What is minus 3? Minus 3 is minus the 5 plus the 2. So, if I have 5 and I want to take away the 3, it's minus the 5 plus the 2. Oh, yeah. Do you, Lewis? I think you can cancel the order and reorder, and then you'd get everything. Riri. So you have to. This is the formula you had to know. That's all it is. Yeah. So when we do it. Hey, nice tree. Welcome. It's so late for you. Yeah, Lewis, if you want to just cancel your order, you should be able to cancel your order and then order the big one. If you count the beads individually, you're still adding. Oh, I'm sorry. So you count the beads individually still when adding. I'm still confused how to move the beads. Oh, stop by. I'm gonna have a good night, Nice Tree. Thank you so much for dropping by. Beads individually. 5. Okay, we do the 5. Let's try this again. So if I have 5, I see you shift the beads instead of moving one by one. So So if I take away the 5, I need to plus the 2. 1, 2. They see you shift the beads instead of moving one by one. But it's a 3. If we need to take away the 3, we have 5. We have to take away the 3. To take away the 3, we have to take this away. We have to take away these 3 beads. So we minus the 5, but we have to plus the 2. So we have to minus the 5. So if we have the 5, we have to take this away. Take away the 5, take away the 3, but we have to add these 2 back. That's why it's a 3. Item 14. What you have on the screen. Yeah, but you know what? It comes with it. The big bundle comes with it. Hold on. This one. Number 9 comes with everything. Oh, but it doesn't come with the okay, wait. Number 9 comes with this book. But no, you're right. No Christmas and no Halloween. That's the problem. I didn't do that bundle. But it comes with everything else. So, it comes with this one. It comes with that. And then I have the 5, the minus 5, the 10, and the minus 10, and the plus 10. So it comes with those ones. But you're right. It doesn't come with the Christmas or the Halloween. So, I don't know. I guess you're okay. Yeah, you're okay if you just want to order that. No, thank you, Jeremiah, for your patience. You move the beads in cluster. For an adult to learn the abacus, which one recommend? Oh! Thank you so much, Jeremiah. Do I go live often? Yes, I go live every day. Sometimes twice. Jeremiah, that was funny. I was like, look at the screen. So funny. Okay. Okay. So, Riri, Rai, I would suggest this one. Nope, that's too large. Thank you, Jeremiah. Rai. Yeah. So there is an abacus for adult, but it's over here, and my name is, and this is my name. Hello. It's available over here. It's not in my TikTok shop yet, but it will be. I just haven't made the. I just waiting for the shipment to come in. Thank you, Jeremiah. Thank you, Jeremiah. I appreciate that. Oh, okay. So, let's see. Counting the beads. Did I answer your question? Move number 2, slide all the way up. 4. Move number 2. Move number 2. All the way up. I'm not sure I understand that. Move number 2. Sorry, Missa, I'm not understanding. This one? All 4 up. I don't know. So when we're looking, we do... Oh, I see. So, right. We have to take away the 5. The question is what? 5 minus 3. That's the question. So if the question is 5, take away the 3, we got to break up this. We have to break this up. That's what we have to do. So we have to break this and take away the 3. But if I take away this whole thing, that's too much. I got to add the 2 back. Right? Did that make sense? I have to add the 2 back. So that's why I have to break this apart and I have to add the 2 back. That's what I got to do. So I take away the 5, but I have to add the 2 back. That's why I have to do that. Yeah. Okay. Okay. Multiplication. Are we ready for multiplication again? Move. Yeah. Yes. Yes. Because if you take away, because if you take away the 5, you've taken away too much. So you have to add the 2 back. I'm getting there. I'm going to need you to start from the top. I'm not real, and neither are you. Move the 5. Yes. So that's what it is, right? So you have to understand that if we take it away, that's too much. We got to put the 2 back. So move number 1 is minus the 5. Yes. Right? Minus the 5. And then 4 1 beads. Well, for this one, it's 2. Because the question is minus the 3. That's what it is. This is 2. This is 3. So we're doing a little review. If I cancel, can I buy again and add? Yeah, you can cancel and buy it again. Because I didn't process anything. So you should be fine. Yeah. But I didn't make it a bundle. I didn't think anybody would want it. So, yeah, you can, yeah. I think what you did before is fine. And then you just add everything. Because then you get free shipping. And I think there's a coupon. I don't know if there's a coupon. I was trying to get coupons, but I'm not sure how to get the coupons. So if the 5 is like a 1 then, when you're subtracting, since you're adding it back, or no? No, you're not really adding, no, 5 is not like a 1. 5 is like a 5. Right? There's 5 cubes. How much are you going to take away? Do you take away 4? Then you have to add back the 1. But if you take away 3, you have to add back the 2. If you take away the 2, you have to add back the 3. If you take away 1, you have to add back the 4. Each move is subtracting 1 from the total. Yes. Siren, did that make sense? So it all depends on, I meant adding the 2 back. Yeah. Because we have to give you, because if we take this whole thing away, we have nothing, and then it's wrong. Because we want to only take away 3, we got to break this apart. She means not 5 is like a 1. Right. Blue takes away the 1. So here is, subtraction is always more difficult because we don't do subtraction very much. Blue takes away the 1 with the 3. Exactly. So if we take away the blue, we have to take away the 3, but we got to move it back to 1, to this. Try showing her move the 5 up at the same time. So if I did this, do that. Hey, Aces, welcome back. Yes, it is midnight math. So yeah, if we want to 5 minus 1. So the question is 5 minus 1. If that's what the question is, 5 minus 1, you got to do this. Because why? Here's my 5. I got to take away the 1. I'm going to take away this 1. I got to move this back to my abacus. So I have to add the 4. Then minus the 2 to have a total of minus 3. No. That's not how we do it in abacus. With abacus, what we do is the formula, because we want to 3 and 2. Not a problem, Lewis. No, yeah, not a problem. Not a problem. I'm happy it worked out for you. So we have to know how to make a 5. We add the 5, make a 5. We need to remember these formulas. We need to remember the partners. The partner is 3 and 2. 2 and 3. So if we're going to take away the 3, we have to find the 2. So that's why we do this. We have the 5. I want to take away 3. 1, 2, 3. But because I take away the 3, I have to add the 2 back. Minus the 5, add the 2. So yeah, have a good night, Lewis. I hope to catch you later. Oh, sorry, Jeremiah. Thank you. You too. Sleep well. So the subtract head doesn't really show the abacus because it's the one being taken away. Yes, I'll keep practicing what I know so far. Okay. Thank you, Kazar. Thank you so much for liking the live. Thank you so much for checking in. Yeah. So this one specifically, so the subtract head doesn't really show on the abacus. Yes, because this one specifically is a formula. Just like how we add, right? When we add, we do 2 plus 3. When we do the 3, it's the same way. Plus the 5 minus the 2. Now it's the reverse. It's minus the 5 plus the 2. So this is the reverse of this. When we add 2, we want to add the 3. To add the 3, it's plus the 5 minus 2. When we subtract the 3, it's minus the 5 plus the 2. Thank you for the follow. Thank you for checking in, Aces. I'm getting it more now. Yeah. So, and that's what we're trying to do. So we do 3 plus 3. 3, what do we do? Plus the 5 minus 2. Okay? Plus the 5 minus the 2. So let's do it now. 6 minus 3. 6 minus 3. Minus the 5 plus the 2. Minus the 5 plus the 2. Because why? It's the 5 that we're utilizing. The 5 is the constant. See how we add the 5 or we subtract the 5? And then we just have to figure out how to balance the equation. I see. You're doing a plus 5. Yes. I'm doing a plus 5. We're only adding a 5 or we only take away the 5. Yeah. And that's what it is we need to understand how the fact family of 3 and 2 and 1 and 4. Is 5 always use the result? Yes. 5 and 10. 5 and 10. So when we subtract, It's the same thing. The formulas will use the beads. Yes. So the formula will be used to move the beads. Yes. The formula is if you don't have enough. That is why we do it. If you don't have enough, you have to use the formula. So here's my question. 5 minus 5 is equal to minus the 10. Right? 5 minus 5 is equal to minus the 10. So here's the formula. Minus the 5 is equal to minus the 10 plus the 5. So when we minus the 10, right, 11, we do 11. We don't have any more beads to take away the 5. We don't have any beads. So we need to do the formula. The formula is what? Minus the 10 plus the 5. Minus the 10 plus the 5. I was thinking it was an individual counting, only moving when we come into play. Yeah. The way you were mentioning it, it sounded like it was more counting up. But in this specific methodology of abacus, we don't count up. We use the concept. And that's the difference. The difference is that we in abacus world we use the concept of minus the 5 and add the 5. Minus the 10 and plus the 10. It's very similar to making the 10. Yeah, that's what I was thinking. Yeah, we're not counting up. The Chinese abacus counts up, which is very interesting. But in Japanese, the way they figured it out, we don't need to. We just need to know our fact family. These are our fact families that you need to memorize. When you understand these fact families, that's what makes it critical. Then you start doing critical thinking, which is very interesting. Yeah. So you only use the formula when you don't have enough beads. So much faster. It is so much faster. It's crazy how fast it is. It's so crazy. And that's what makes it so interesting. And then that's also what provides critical thinking too, which is really interesting because that's where this one comes in and you start talking about workflows. This is where critical thinking comes in. So we have 7 on the abacus. 7. I want to add the 4. Can I do it? No, I cannot add the 4. What do? Can I do the 5? Can I do the 5? No, I've already used the 5. So what do? We have to we have to add the 10. Adding the 10 is what? Plus the 10 minus the 6. So my final answer is 11. So we talk about, then this is when you start talking about critical thinking. Yeah, plus the 10 minus the 6. Thank you, Carlos. Yes, plus the 10 minus the 6. Crazy, right? Crazy. But yeah, it's so amazing like how fast it is. Oh, thank you, Miley. I appreciate that. And so what we do is we just break down the concept of how to make a 10 and how to make a 5. But the biggest thing is understanding the concepts of the fact families. And these are the fact families that we have to memorize. Thank you everybody for joining. For those of you that are interested, I am here to show you, because I am here to show the matrix what an abacus is.
Welcome to the real world.
So for those of you that just joined, thank you so much. And go ahead and check in. Over here on my head, there is an orange heart. Orange heart me. So we're going to count. We're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. And that's it. So what we're doing is we're counting on the abacus, right? This is 10. This is 1 and a 0. When we look, every column is a place value. So we have our ones, tens, hundreds, thousands, 10,000s. Ones. So this is 10. This is 1. This is 100, 100. This is 1,000, 1000. And then this is 10,000, 10,000. That's it. This is our decimal. The decimal sits between our tenths, ones and our tenths. That's where the decimal is. So we can do hundreds, tenths, and hundreds. 1.34. 1.34. So that's what it is. And so what we're doing is we're counting on the abacus. We have our ones, tens, hundreds, thousands, and 10,000s. Okay. How are we doing? I need to figure out what. I had my students mark with red marker where the decimal is on the outside. Oh, yeah. Yeah, you know, that's interesting. What my brother does is he uses the stickers to tell you where the ones place is. What's 160? 100, 6, 100, 0, 6, 5, 6, and then 1. 5. 165. Right? And then when we look, we can do 7. You can do 6, 7, 6, 7, right? 5, 6, 7. 1, 6, 7. And then we have 9. That's 9. 5, 6, 7, 8, 9. So this is thousands. This is 9,167. 65. They get lost because the natural dot is on the abacus, confuses them. That's funny. Hey, Nirvana, welcome back. Not a problem, Hungry Hugh. Not a problem. I'm happy that it's a proper question. You know what I mean? Because I do get some trolls. And they'll be like, 6, 7, 6, 7. It's not 6, 7. Yeah, not a problem. So when we're looking, right, we have our decimals. Oh, yeah, that's interesting. That this confuses them. But then if you want to, right, we have our ones and then we have our thousands. This is our thousands. Because this is our thousands, notice that everyone is grouped. This is like a comma. So we have our ones, tens, hundreds, thousands. But if you wanted to, you could choose this as your ones and you just move everything over. Then we do that. So we have our ones, tens, but notice I have no more room for thousands. So we do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 20, 30, 40, 50, 60, 70, 80, 90, but no room for hundreds. However, it does look like this when we you can make a really small make a really small number. So we have 9, 90, 90, right? This is my ones place. 0.00001. That's what that would look like. Missa, how old are the students? I would work for trailing and repeating decimals. Work that. Would that work for trailing or repeating decimals? Yes, because you talk about the ones. That's why I don't label this as my ones or my decimals here, because you can choose any one of these to be your ones place. So if I had this number here, I can have my ones here, or I can have my ones here, right? That's why I don't do the decimals. That's why I don't put the decimals, because it gets too confusing. They just need to know that these are labels, and then these labels are markers for groupings of the columns. So like the column groups. Oh, I see. Yeah. And you're teaching them the 1 and 4 abacus? Excuse me. So like this question here, if I did 25, we have 25, 2, 5, we do 3, 1, 2, 3, we do 2, 1, 2, this is 1, and then we do 5. Notice that the 5 is a comma, and then we have 6. That's what 6 looks like. But then if I need to do these two, I have to change it to this, right? Because size matters. So we could do again 2, 5. My ones is here. This would be 3, 2, 1, 5, 6, 7, 9. Yes, because I have many that don't know their math facts. Whoa, really? Miscount and then add it up. That's so interesting. Yeah, I think it has a lot to do with COVID, right? Like my kid, he doesn't read so well, so I had to make sure he read. So he's been reading a chapter a day. Crazy. I think it has a lot to do with the COVID. You know what I mean? And it's tough. It's real tough. Yeah, it helps a lot to visualize the actual 1 and 4 because they can see the numbers. Yeah. Yeah, that's really good, Missa, if that makes sense. No, it does make sense. Because I've been doing a lot of revelations on trying to figure out like other ways to explain. Because I do have a lot of adults that come by and sometimes they get a little mixed up with the formulas or with the. Get a little mixed up with the formulas or they get a little bit mixed up with it's just the formulas. And so I have it where I can explain. I have a really good way of explaining like how to do it. Can you? Yeah, not a problem. Thank you, Mark, for the question. Hello, PD. Thank you so much for joining. So let's go something simple. Because you need to understand the concept, right? So the first thing we understand is what? We're going to add the 5. We can add the 5 and then plus 3, right? Do we have enough? Yeah, we can have enough. Place value is also lacking. That's really interesting. So what we did 5 plus 3 is equal to 8. I need directions. Okay, so 5 plus 3 is equal to 8. And then what? We do 4. When we do 4, what are we doing? We do 4 plus 4. 4, and then plus another 4. To plus another 4, what do? We have to do a formula. The formula is excuse me, this. We do 4. 1, 2, 3, 4. We do 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We need to add the 5. We have to have 4. Yes, exactly. Thank you, Missa. So we have to plus the 5. Here's my nickel. We plus the 5, but that's too much. I have to take away the 1. So I got to take away the 1. So my final answer is 8. 5, 6, 7, 8. I can do it again on the abacus. I can add the 5, take away the 1, and my final answer is 8. 5, 6, 7, 8. So, have you? Do they? Is your students confused about the 5 right here, or are they okay with that? Because the way I've been explaining, that's the way I've been explaining it was with the bricks, with the cubes, and I think that's been helpful. So what I did is I didn't glue it. I taped my bricks together, so then they can actually see the cubes. But then you can show that you can take away whatever cube it is, which is interesting. So that's what it is. Hello, everybody. Wow, I got like 200 people in my room. Thank you so much for liking the live. I'm at 23,000. Hello, Perez. Welcome. Welcome. Welcome to Midnight Math. Thank you for the follow, Kuya Rix. Yeah. Okay. I have been on for a little bit. Tyrant Carnage. Thank you for the follow, Tyler. Thank you for checking in. Thank you for checking in. I'm at work. I need to leave like right now. Thank you so much for liking my shirt. Oh my god, you work so late. I'm going to leave right now. Okay. Yeah. Oh yeah. So, I've been on for a little bit. I think I need to go to the I need to figure out like bath. So they understand the 5. I've used the 5 with the dollar bill. We'll be replacing with the coins. Yeah. Yeah. The coins I think would be good. The dollar bills are fine too, but it's a little expensive, you know. But you could also do with the bricks too. What time do I wake up? I don't know. I try to wake up at 6. Missa, you might want to try with the bricks and then tape it, and then that might help too, depending on how they understand how to take away the 5 and adding of the 5. And that's what I did. I actually have a couple where I taped it, so that might help too. We have the plastic coins, plenty. Oh, you could do the coins, or you can also do the bricks too, right? Or you could tape 5 pennies together, because you have to tape it, right? Because if you tape it, that represents the top bead. I think if you taped it, that would be beneficial. Tape 5 pennies together. Oh, that'd be brilliant. Tape 5 pennies together. Yeah. Yeah, if you don't have these, and if you have plenty of plastic coins, I would tape 5 pennies together, and that would equal to the 5 nickel. That would equal to the nickel, right? And then they can see individual one. But because you tape it all, they can't break it. Back to elementary. Yeah, I think so. You know what I mean? Because it's always good to see the numbers, and because the 5 is a little bit of a difficult concept, right? But I think if you can get the 5, then doing the 10 is easier. Yeah. Yeah, I think the 10 would be easier if you taped the pennies together. So I would tape 5 pennies. Thank you for the conversation. I how did I want to do I wanted to do music. I forgot how to do the music. Tools? Go live. Subscription. Play together. Nope. Goal? Nope. I forgot how to play the music. Ah, that's right. Playbook, fan club, promote, live events. Yeah. How are we doing? Okay. So, any more questions? How are we doing? We're all right? Thank you so much for liking the live. Woof! 24,000. Yeah. I'll experiment with taping pennies, but they'll understand the nickel. Yeah. Okay. Good luck. Yeah. I mean, if they understand it, that'd be great. That's great if they understand it. Audio mixer. No? How do I? Nope. Nope. This one? Nope. I had it. I was trying to figure out how to play music. Is that it? No. Transition. Oh, system. Nope. Background music? Nope. Anyways, sorry. Sorry. Okay, I'll be back for your next live work to work on the multiplication piece. Do you want to do multiplication right now? We could do it right now. Cause you're the only one talking to me. Out of like 200 people, you're the only one talking. So we could do multiplication. I'm trying to figure out like background music, but I can't find it. All right. Do you want to do it right now? We could do it right now. Yeah. Okay, great. Okay. It's 8. It is. Yes, you're right. Thank you, Mexi. It is 8. I gotta get this going. And I gotta get this going. Okay, so. Okay. But can you hold on for just a minute, Missa? I need to go to the bathroom because I haven't gone yet. Let me go to the bathroom. I'll be right back. I'll be right back. Okay. Sorry. Whew, because I've been on for 4.5 hours. My God. Okay. Here we are. So, did we talk about this? Okay. We're going to do multiplication. Now, multiplication. I'm trying something different. Okay. So, on the abacus, what we're going to do is we're going to do distributive property. Distributive property, just in case you don't know, it's a math rule. What we're going to do is we're going to break up the numbers into smaller parts, right? So we have and what we're going to do is we're going to multiply the parts separately. When we look at abacus, you really sound like a teacher with no... Woo. Yeah. Okay, so here we have to count the amount of digits. Oh, you know what? We'll do it with this. Okay. I'm going to do a side by side. In the abacus world, we have to count our numbers. 1, 2, 3. 1, 2, 3. This is why. Because then we're going to do 4 times 5. 4 times 5 is equal to 20, right? Add the 2, add the 0, which is very different than mainstream. Mainstream, you have to do 50 times 4. And that will give you 200. But because we're on the abacus, we already see it's 200. So we don't need to do that. We just need to keep it simple, right? 4 times 5 is equal to 20. What's next? 3 times 4. 4 times 3 is equal to 12. Again, add the 1, add the 2. That's it. So my final answer is 212. 212. Did that make sense? And it's the same process again. What is it? 212. 212. Right? And we do it again. So we do our times table. We know 3. 1, 2, 3. 1, 2, 3. The reason why is you want to critically think what our question is. Our question already gives us our answer that it's going to be somewhere in the hundreds. Right? That's how we figure it out. It's going to be somewhere in the hundreds. So we do 5 times 4. 5 times 4 is equal to 20. Add the 2, add the 0. 5 times 5 is equal to 25. Add the 2, add the 5. So my final answer is 225. Missa, did that make sense? Hey, Doa. Hi, Jake. DOA, Jake. Hello, Jake. Missa, did that make sense? Are you new, Jake? It's similar to the Japanese lines, but it's distributive property, actually. Thank you for the follow. And we actually don't, and yeah. But the Japanese lines is really what? It's a 1-to-1. Whereas this is memorizing your multiplication facts. So this would be after your Japanese lines. Yeah, that's what it would be. In the process of learning, you can use the Japanese lines, but I feel like it would be like elementary. And then everybody knows their multiplication fact. Once you know your multiplication fact, then you could do division. The Japanese is actually counting backwards and counting dots. I only know counting dots then. Yeah, I only know how to count the dots. Because I only know it's all about intersection, right? Isn't it all about intersection? So if I did, I don't know, 3, 4, 5, 1, 2. Yeah, I think I only know it's all about the intersections. But then I don't know how you do. I don't know how you do 52. What was the question? 45. I don't know how you do 45 times that by 5 with the Japanese lines. I would have to figure, I don't know. I'd have to research on that. Yeah, I don't know. I'd have to research on that. I don't know how you would do that. Draw 4 lines. 1, 2, 3, 4. 1, 2, 3, 4, 5. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 20. Oh, I see. 1, 2, 3, 4. 1, 2, 3, 4, 5. Oh, that's how you do it? Oh, and then you do this. 1, 2, 3, 4, 5. Right? Oh, but then, I guess. So this would be 1, 2, 3. This would be 20, and then this would be 25. And then count all the intersections. That's a lot of counting. I see. Right. Yeah, I remember looking at it. I was like, I think this is before. I think this concept is before memorizing 5 times 4 and then 5 times 5. Yeah. Or the other way. 5 times 4 and then 5 times 5. No, that's right. Yeah. I think they need to, for the abacus to work. Yeah. The lines is before learning Yeah, I see that. Yeah, I see that. The lines is before distributive property. Yeah. But that would suck if they didn't know. So, you could do cumulative addition, right, on the abacus. They actually need, yeah. So what I do is I tell the kids 1 times 3 is 3. 1 times 2, 2 times 3, you have to add another 3. Add 3. 3 times 3 is 9. 1, 2, 3. And then you do it again. 3 times 4, right? Add another 3, right? And then 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. Do you do cumulative addition with them? That's what I wonder. Oh my God, really? Here. Hold on. I put it in my Abacus for Adults. I actually made it. I made it for my adult book. And then I have a dinosaur one. Hold on. Here. I have a dinosaur one. I created one for the dinosaurs. I mean, this is like, ugh. So, let me see. They learn to multiply first by using repeated addition. Yes. So what I was doing is I wanted to show them, I don't know if you can see that. I wanted to show them if it's 3 times 1 is 3, right? You do 3. And then I was going to actually add more because I wanted them to know how to do it with the abacus. So with the abacus, 3 times 3. So use this to count your numbers, right? 3 times 2 is 3. 1, 2, that's 1. And then I have to add another 3 plus the 5 minus the 2, right? And then I add a 3, right? 3 times 3 is add a 3 again. I didn't know how to get them to keep up with their repetitions. Yeah, use the far left. That's what I would do. Yeah. And then you get them to add and subtract the 3 depending on where it is. But yeah, that's what I would do. So 1, 2, 3, 4. Yeah. This is great. Thank you, Missa, for joining. Who would have thunk it? What book is this? This is my times table book. It's not available as a book yet, but I'm trying to make it into a book. And so I have the different activities, but then what I did here was I was trying to show adding and subtracting of the 1 and then adding and the subtracting of the 3. See how I have it here? Adding and the minus, and then this is like a story, right? And then they were I wanted them to count all the plates. And then I have a little story to go with it. And then we talk about the 3 times 7. And then what I wanted to do is afterwards we talk about like the different additive addition. And then, but I'm going to update it. I want to update it because I want to put in the abacus formulas here. And then there's a maze. You got to figure out the maze. And then after that, I'm going to add in division because you need to know the division. You need to know your missing factors, but you need to know how to do the division. And that's the plan. But I haven't worked on it for a while. It's been about a month or so. No, it's been about a year or so. But this specific copy is available in the TPT store if you're looking for it. But I want to do. Every number is going to be a book. Every number is going to be a book. Yes, when you have the book out, this is the connection between, yes, the first, yes, and the formulas. Yes. Because what I want to do is I'm going to introduce multiplication right before, I'm going to start with 1, 2, 3, 4, 5 after making of the 10. And then I do 6, 7, 8, 9 after the two-step equation. So, yeah, but the book, the way I wanted to have the book, every book will be one number. Because I didn't like the fact that the other the other multiplication books that I see, they go through the whole series without solidifying the concept of the numbers. So I wanted to have every book will have one number. So there's a 3 times table, 4 times table, a specific number. Yeah. Yeah. But yeah, that's the plan. And I'm just trying to get more Abacus out there, more out the door. So they gloss over repeated addition and assuming yes, exactly. They assume yeah. I know they're starting to do like arrays as well, right? So there was these arrays. They're starting to do arrays, and I'm like, that's okay. I mean, it kind of makes sense. 1, 2, 3, 4, yeah. And then you have to count it. You could do arrays. What was the other one? Skip counting. There was going to be skip counting, right? What else was there? I was teaching a student. He's 5, but like he knows his multiplication, but he doesn't know why. And so I was telling him, okay, you need to have your squares, and then you need to figure out like what's inside it. So there's 2 inside it, right? So this is like 3 times 2 or 2 times 3, and then I have boxes. 1, 2, 3, 1, 2, 3. Yeah. Can we do? Yeah, not a problem. Okay. So, I don't know. What's a 2? I don't know. If you want to do I don't know. What number do I? Array, skip counting, partial products, number lines. We have to teach all. Yeah. Yeah, we have to teach all the ways. I was explaining that to my student as well, just so that he was exposed to it. Parents think it's new math. Yeah. Let's do 53 times that by 87. Right? So again, 2-step. 52. Oh, 52? All right. 52 times that by what? Do you have a number? Oh, you want to do that? 83. Okay. So the first thing we're going to do is we're going to count our digits. 1, 2, 3, 4. 1, 2, 3, 4. One, two, three, 4. 8 times 5 is equal to 40. 4, 0. 8 times 2, 8 times 3 is equal to 24. Add the 2, add the 4. We're done with this. We're going to count again. 1, 2, 3. 1, 2, 3. 5 times 3 is equal to 15. add the 1, add the 5. 3 times 3 is 9. 9 is a single digit. You have to 0, 9. 0, 9. That's it. So my final answer is 4, 3, 8, 8. No, 9. Sorry. 9, 9. 9, 9. Thank you, John, for sharing my life. Yeah. 1, 2, 3, 4. 8 times 5. Let's do a review and then we'll do another one. 8 times 5 is 40. 4, 0. 8 times 3 is 24. 2, 4. We're done here, right? So we got to do this 3. 1, 2, 3. 1, 2, 3. 3 times 5, 15. Add the 1, add the 5. 3 times 3 is 9. 9's a single digit. I have to make it a double digit. 0, 9. That was an easy one. So my final answer is 4, 3, 9. Excuse me, 9. Let me... The recount when you move. Yes, you have to recount it because you're done with this. You're done with the 8. Yep. Yeah, you have to recount it. I usually recount it. So we can do another one. That's where I got lost. Recounting. Oh, makes sense. Oh, okay, good. Yeah, you have to recount because it's double digit. That's why. There's 2 digits, so you have to recount it. It's just like in mainstream, right? Mainstream is what? 3, 8, 3. So what do? You do this, 9. You do this, 15, right? Then you got to recount. You have the 0. So what do? 8 times is 4 and then 2. 8 times 40, right? 4, 2. Same thing. We recount. This is where we recount. So we do 9, 9, 3, 4. Yeah. It's funny when you do it on the abacus, right? Because we do this first on the abacus. We do 4. So we do, yeah. So it's 4, 0, 2, 4. We do this first. And then we do this. We do 1, 5, 9. Yeah. This is the recounting. Yeah. Oh, thank you. Hello. Oh my God, there's like 250 people in the room, but there's only 2 people talking to me. Funny. Yeah, it's tough though to find good questions like that because there's no formulas involved. What else? Hey, lady, can you do another problem or lift up a little bit, a little higher, like that? How are you counting on the obvious? Lady, yeah, let's do that. I've learned. Oh, hey, welcome everybody, welcome. Passive learning, learning by osmosis while you sleep. I hope I can put people to sleep. It's obvious a little higher. Oh, if the obvious a little higher, that's all there is. Yeah, that's all there is. So let's do a review. 1, 2, 3, 4, and then 5. We have 6, 7, 8, 9, and then 10. That's what 10 looks like. We have 11, 12, 13, 14, and then 15. 16, 17, 18, 19, and then 20. That's what 20 is. 2 and a 0, right? So what we did here is 8 times 5 is 40. We had to count our digits, right? To find our place value. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we know we're going to be somewhere in the thousands. So then what do? We do 8 times 5. 8 times 5 is 40. 4, 0. And then we have to do 8 times 3. 8 times 3 is 24. We recount. We're done with this. We recount. We do 3, 1, 2, 3. 1, 2, 3. And then we did what? 3 times 5 is 15. 1, 5. 3 times 3 is 9. 9 is a single digit. You go back one column. 0, 9. Add the 9. That's what we did. So here is the mainstream way, right? This is the abacus way. If the obvious a little higher. Yeah. So if I did, still confusing. Oh, sorry. Crucial? Here we go. So let's count. 1, 2, 3. 1, 2, 3. Anytime the beads are touching the horizontal bar, that's what's being counted. This is 3. Thank you so much for sharing the live, John. Thank you, Stephanie. Oh, thank you, Stephanie. So this is 4. 1, 2, 3, 4. It takes a little bit of practice, but don't forget we're like intermediate right now, and we got to go back. Let's go back. Let's take a few steps back. 1, 2, 3, 4. Let's count. Let's see it right. The nerd in me lined up the numbers for each answer, and you can see the lineup. I've never seen anything like it. Blow my mind. How can you add on that? Hold on. Let's count, right? 4. 1, 2, 3, 4. 5. The top beat is 5. The top beat will always be 5. No matter what. The top beat will always be 5. So we have 5, 6, 7, 5, 6, 7. 5 plus 2 is 7. 5 plus 3 is 8. 5 plus 4 is 9. That's 10. Because after 9 is 10. Every column is a place value. Here it is. Like that. So we have every column. Doesn't matter where you start. It does a little bit. This is where our label is. This is the label. This is my ones. So that's where I would start. So ones, tens, hundreds, thousands, 10,000s. 1, 10, 100, 1,000, 10,000. Yeah, place value. Yeah, every column is a place value. Every column is a place value. So when we're looking, the top beat is always 5. This is 5. 555. 555. 5,555. 55,555. I love she's counting to us like we're in kindergarten and it's working. No, you're not in kindergarten. This is just unfamiliar. And if it's unfamiliar, then you just need to understand it. That's all. Because if I just gave you this, right, it's easy to see. But knowing this, you don't know what it is. Just unfamiliar. Good teaching to me. Thank you. So when we're looking, we have our number. I love the way you explain it because I definitely don't understand it. Yeah, see, that's what I'm saying. It's just unfamiliar. I'm not trying to patronize you and I'm not counting like it's you guys are in kindergarten. You don't know. You don't know. So here, let's do this. Let's do this. Okay, we're going to do this. This is a maze. Let's see what number this is. What number do we have? I'm going to find what number? This one? Yeah, we'll do this one. So we have our number. We have our 4-digit number. So we have our 4-digit number. This is thousands, hundreds, tens, and ones. What number do we think this is? What number do we think that is? Oh, thank you, Missa. Yes, 9, 5, 6, 7, 8, 9. 9. This is 4. 1, 2, 3, 4. This is 0 because it has a placeholder. Thank you, C, not 1. And this is 1. Well done. Well done. 1,000 goes like this. All right, our next number. We have our thousands, hundreds, tens, and ones. Thousands, hundreds, tens, and ones. What number do you think that is? 7, 7, 7, 7, 3, 6. You thought. Seven? Lady Di, do you see that? Hold on, Maddie. Hold on, Maddie. Lady Di, do you see that this is 7? 7 starts over here. 6. So we're a little bit backwards. This is the ones. This is the tens. This is the hundreds and thousands. So we read from left to right. 7, 7, 3, 6. Does that make sense? Yeah. So we read from left to right. Thank you. Yes, thank you. I did it. I was like making sure that it wasn't a troll. You know? Yeah. So that's what the number is. 7736. 7736. Hold on, Maddie. Here we go. We're going to count on the abacus. Oh, thank you, Stephanie. 1. Anytime the beads are touching the horizontal bar, it's being counted. That's 1. This is 2. 1, 2. 3. 1, 2, 3. 4. Because these beads are touching, right, it is considered counted. So this is 5. we have 6, 7, 5, 6, 7, 8, 5, 6, 7, 8, and then 9. 9. 5, 6, 7, 8, 9. And then that's 10. So then our question is 1, well done. So it's dependent on how many times you slide the bottom ones up. Yes. Every bottom bead has a value of 1. Every bottom bead is a value of 1. Every top bead is a value of 5. So this will always be 5. So this is 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. 4, 1, 2, 3, 4 plus 5 is 9. Well done. Yes. 1,463. 1,463. Thank you, syntax. I'm going to learn my ultimate life. I have seen so many people use this and they're super fast. And I'm like, how? Yeah. I would practice. I would have to practice with that one. Yes. Yes. It's about practicing. That's what it is. Okay? So we have 1,000. That's what it is. 1,460. I'm going to... Thank you. I do have mazes available. So this one is a 4-digit maze. I do have a 3-digit maze and a 2-digit maze. If I can get my maze books out. So if you're interested, I do have a 3-digit maze as well. It's this one. And it comes with an abacus. That's a 3-digit maze. So this one is a 4-digit maze, and I'm still trying to stock my TikTok shop. But if you're interested, I do have other books available here. Hello, my name is Lynette, and I am an abacus teacher. Yes, the videos with the kids using a pointer thumb. Yeah. Thank you, Corey. So we have 1, 7. That's 7. 5, 6, 7. We have 2, 1, 2, and then 6. 5, 6. Yep, well done. Thank you, Lady Di. Thank you, Corey. Yes. 1,206. 1,726. There we go. So our next number is this. Thousands, hundreds, tens, and ones. Hundreds, thousands, hundreds, tens, and ones. Thank you for the follow, Corey. Thank you, Missa. Yes. 5,876. Well done. $5,876. So we have our next number, thousands, hundreds, tens, and ones. Thousands, hundreds, tens, and ones. I can't. It's crazy on how many people there are here. Thank you, Corey. It is 9, 5, 6, 7, 8, 9. We have 7, 5, 6, 7. We have 4, 1, 2, 3, 4. And then we have 9, 5, 6, 7, 8, 9. I don't have that yet, Stephanie. I don't have the 4-digit maze book yet. It is coming, but it will be a couple of weeks. If you're looking, but I will be making it into a bundle later. The only thing I have as high is the 3 digits. That's as high as I got right now. So I have 3 digits. So we talk about the hundreds, the tens, and the ones. And that comes within Abacus. And then it's the same thing but it's just talking about the hundreds, tens, and the ones. And it's the mazes. I give you the mask maze. The mask maze is available for download because I noticed that the paper is a little thin. So you have the option to download it, and then you can print it on any piece of paper that you like. This one is a file. And then I have this thing called a reverse maze. The reverse maze is I give you the path, right? I give you the path, but then you're going to have to tell me what the number is. And I lost my pen. Sorry. Yeah. So the 3-digit maze comes with the abacus. Okay, thank you, Stephanie. So we have our thousands, hundreds, tens, and ones. There we go. Here it is. Oh, good. Thank you, Carter. Yes. Thank you, Victoria. Thank you, Stephanie. Yes. 2, 4, 3, 9. Thank you, tomato soup. Well done. We'll do that one. Okay. And then that would be, nope, that's this one. 200, 2,000, 439. So we have this next number. We have our thousands, hundreds, tens, and ones. Why is there a 4 at the end? What's the 4 at the end? What 4? There's a 9. Hello, Carter. How you doing? Thank you for the follow, John. Yes, thank you, Carter. 2,677. Thank you, Lady. Thank you, Lady Di. Thank you, Tomato Soup. I'm tired, but I'm ready to learn. Yeah, I'm tired too. But we're okay. We're okay. Thank you, Stephanie. So we have our thousands, hundreds, excuse me, 1, 2, and then that, tens and ones. I'm coming down from my high. 1,000, not 400. Thank you, 900, 0, 9. Thank you, Corey. Thank you for the follow, Lady Di. Yes, that's what it is. Thank you, Corey. So we have our next number. tens, and ones. Yep. Oh, oops. 500, 5,000, 0, 9, 4. Thank you. Thank you, Stephanie. Thank you, Lady Di. Thank you, Lady Di. Thank you. Elle loves God. We have hundreds, tens, and ones. Thousands, hundreds, tens. I'm in love with the math a new way. Or you said you're on Amazon? Yes. I'm putting a few of your Abacus books and bundles. Oh, that's so awesome! Yes, I am. Good luck. Good luck, good luck, good luck. That's my name. Yes, 7,570. That's awesome. Yeah, I'm working on book number 15. I can't believe how many books I've got. It's pretty awesome. But thank you so much, Missa. Oh, we're done. Our last number. Our last number. All right. We have our thousands, our hundreds, our tens, and our ones. Hundreds, thousands, hundreds, tens, and ones. Oh, my gosh. Thank you, Lady Di. Yes, 7,266. Well done. 7,266. Well done, Stephanie. Thank you, guys. Thank you. Thank you. Thank you. Thank you. I can't believe how many people there are. I don't think I've ever had this many people at the same time. Got it. Sending you my other math teachers. Thank you so much. Well, no. We'll see what happens. Yeah, we'll see what happens. It's trying to educate the rest of the matrix. You know what I mean? Thank you everybody for joining. Please keep your mind open.
Now, open your mind to me, please. Open your mind.
Oh my god, I don't know if you've heard all of my sound bites, Missa. How often do I go live? Every day. Every day. Can you do mental math? No, I cannot. I do not do mental abacus. I just teach abacus. That's all. Thank you, everybody. Welcome, welcome, welcome.
Welcome to the real world.
Okay. But you know what? I think I'm going to tap out. I've been on for a little bit, and I think it's time to tap out. But there's like almost 300 people in my friend. I have to get going. Okay, have a good night, Missa. I have several friends who are teachers, and I'm sending them your way. Thank you so much, Stephanie. Thank you so much. I appreciate that. Yeah, usually I have a whole thing, but I've been on for a little bit. Oh, so we talked about how to read the abacus, and then there's a few steps. The next steps is how to move the abacus. Then we do adding, subtraction, and then we could do multiplication, and we do division. Yeah. But I can't believe how many people there are here. Thank you so much, Stephanie. Thank you so much. But yeah, I think I'm gonna tap out. I think I'm gonna tap out. I think I'm gonna head to bed. It's like super. What time is it for you? It's like 1:45 for me right now. That's crazy. That's so many people on right now. This is the most I've ever had. I don't think I've had this many people before. It's 3 a.m. See? It's 3 a.m. You're learning it. You guys are learning math in the middle of the morning. Oh my god, Lady Di. Did you just wake up, or have you been up, Lady Di? Did you just wake up? This is crazy. This is nuts. I've never had this many people in my live before. This is a personal best. Thank you guys, everybody, for joining. When will you be on again? I've been up, got off work. Oh my God, you go. That's really late. I usually go on live one every day. I'm always live every day, at least every day. When will I be on? I was going to be on tomorrow morning. However, I might just come on tomorrow night. I'm trying to be here at 7 or 8 Pacific Standard Time. That's my goal. That's my goal. But yeah, that's crazy. Thank you, Angela, for the follow. Whew. Okay. Yeah, and then we talk about abacus. We talk about how to count on the abacus, how to add, subtract. We did some multiplication here, and then there's a little bit of adding right here. This was a good one. Oh, hopefully I could catch you on this live. This was... Oh, thank you, Lady Di. I apologize for... I've been on for a little bit. Yeah. I mean, but you're tired too, right? Getting off work. What grade math is this? It's the fun grade. Usually, I had to wind down after work. Oh, okay. Oh my goodness. And you like to wind down by learning math? So, like, I feel like the abacus is very comparable to Sudoku, crossword puzzles, jigsaw puzzles, word searches, and I'm gonna bring in abacus. I'm trying to show the Matrix what the abacus is. Hello, RTX, welcome.
Welcome to the real world.
What usually Abacus World teaches kids that are kindergarten, first grade, second grade, third grade. But I'm trying to get them young, and I'm also trying to get them old. So I have some books available. I have preschool books available for young kids as young as 3 years old, 4 years old, 5 years old. And then I'm also starting to teach adults as old as 70 and above, maybe 72 or 73. And yeah, and apparently it's like all grades and all ages. It just depends on how active you want your mind to be. And I do have a few people that are a little bit older, and they are disabled. They feel that they're slowly not thinking fast, but as they go through the abacus method and doing adding and subtracting, they're starting to realize that they're starting to think faster. I'll watch you. I can't wait to do via the abacus. You got old here. Yeah, that's interesting. Yeah, I've got another one. Yeah, I have a few people that are older, and even with yeah, and I do have some people that don't have children and they just want to learn it on their own, which is fantastic. I do have books available in my TikTok shop. I will have the abacus for adults soon. It's just not in stock right now, but I will have it. It is available here if you're looking, and my name is Lynette, and it's over here. Oh, excuse me. Oh, excuse me. Sorry. Yeah. So that's my name. I really like it. And it talks about adding, subtracting. It doesn't do multiplication yet. All right. Yeah. But yeah, I've got books. It's so late. I know it's so late. But you know what? RTX, look how many people there are. I can't believe how many people there are. I'm so amazed. But I don't think I'm going to do this very often. That's really late. Oh yeah, not a problem. Not a problem. But yeah, that's the one thing is it's not available in my shop yet, but it will be. I'm still in the process of restocking my Abacus store, my TikTok shop. And in my TikTok shop, I do sell the Abacus. I also sell a 13 column Abacus. Where is it? Where did it go? Oh, here it is. So a 13 column Abacus. They are both made out of plastic. The one thing is that it's very easy to move, so you have to stabilize the abacus with your left hand. Because if you don't, then if you bump the table, then your answer will become wrong. Because it's easy to get the wrong answer. 13 columns is nice because you can do more, like you could do multiplication and addition, multiplication and division. It's a little bit harder to do multiplication and division on the smaller abacus because you need the space, but these work exactly the same. The colors is only for decoration. So when we look, we have 1 2 3 4, 1 2 3 4. We have 5, that's 5. We have 6 7 8 9, 6 7 8 9, and then 10. That's 10. Can you divide on one? Yes, you can divide on it. But I apologize. I'm not going to do that right now. I will do it in my next live. I've been on for a little bit and I am going to sign off. Thank you everybody for joining. Thank you everybody for joining. I do appreciate everybody for following. Thank you. Have a good night, Lady Di. I haven't seen you in a little bit. Hi. Hello, Jeff. Thank you, Stephanie. Oh yeah, not a problem. Thank you. Thank you, Stephanie. But in the end, if you're interested and you don't catch my lives, I have a lot of videos in my profile. So and then whatever instructions, they're all there. And then if you have any questions, you can just DM me and I'll put a post up. We could do that too. If you don't catch me on a live. Excuse me. All right. I'm good. That's it. I gotta go. I gotta go. Okay. Thank you guys. Thank you everybody for joining. Thank you so much for liking the live and joining and following. Thank you so much. For those of you that are interested, you can go ahead and check in. I will look for you there too. I will follow. Thank you so much. I followed you. No, Jeff. I remember you because it's Geoff. Have a good night. Good night. Good night. Good night. Good night. Have a good night. Thank you guys. Bye.